This conference will now be recorded.
Hey everyone, this is Atul from Team K1 Academy. So first of all, I would like to welcome you on this program. I'm going to give you a quick introduction and walk through how you can make best out of this training and how and what to find where. So this is about Docker and Kubernetes administration. So we are doing 3 programs and I'll walk you through on entire all 3, depending on whether you have one, you bought 2 or you bought all 3. I'll be explaining you as well and what to find where everything inside the portal. So this is Certified Kubernetes Administrator, CK. There'll be CKAD, which is second program, which is for targeted for developers, Certified Kubernetes Application Developer, and Certified Kubernetes App Security or CKS. Now both have, each one of them have 16 module on CK, 18 modules on CKAD, and 7 modules on CKA. This is exactly the way outlined by CNCF, but we are giving a little bit more than that. We are doing both Docker as well as Kubernetes in CKA and CKAD. There'll be lessons, hands-on lab, exam preparation, and the most important part is 1 year on-job support. So you're not getting just the training program, but with that you're getting the hands-on lab. But the most important point is exam preparation and on-job support that we'll be getting. These are the 2 main important things with that. Now, before we go any further, let me share the couple of success stories for 2 reasons. First, to inspire you, and second is that program works. It has worked for a lot of students like you. So if it can work for them, it will definitely work for you as well. Now, Piyush was in his final year last year when he came and said he was inspired like you, and he wanted to do the program, and he was still studying, and he was saying that, oh, can I do, I'm still in my college, will I be able to get a job? And I was so confident in the program, saying that if you complete this program, and if, because he's in India and my team sits in India, I said I'm going to hire you as well if you complete the program and complete all the labs. Since then, he has not only completed the program, he have done the certification and is now doing CKA, Certified Kubernetes Security. So if he can do it, my view is it's not like that he's not good, but everyone else can do, because when someone who just passed out from college can do it, others can do it as well. But it's not just one, but we have a lot of these success stories like that. Tushar, Gargi, we have Vamsi, there's another one here. So this list go on and on. There's a lot of guys are here. Lalita is there. There's a Bronson is here, and Lavanya is here. Like that, there are a lot of guys who have successfully completed the certifications. And as I said, big story. I'm not going to go a lot on here, but this is all to inspire you. Now, we always get excellent feedback on these sessions, and we always strive for the best. And this is what you're going to see as well, that the feedbacks after every session, we are going to ask for the feedback. And main purpose is feedback not for trainer's point of view. We know that we don't compromise on quality of the trainer. Trainer will always be, we've already vetted through it. But sometimes what happens is they may not go at a pace which is comfortable to you. Sometimes they speak too fast, sometimes they speak too slow, or they might be focusing more on theory or more on practical. We are going to focus, this is just to see how we can align better, how can better serve you. So for that reason, uh, if you want to rate us below 5, which is totally fine, you just tell us what we can do next time to make it a 5-star rating or 5-star feedback. Now, apart from that, there are lots and lots of job opportunities. Whatever country you're from, just let us know. We'll help you with finding the job and how you can make this training best. If you're looking for a job, I'll explain you that as well. So there are a lot of job opportunities available in the market, whether you're from US, UK, Europe, Middle East, Singapore, Asia, any part of the Asia or Australia, there are lots and lots of job opportunities. And in fact, good job opportunities available as well. Now, so for you, for job preparation, I would suggest to you is at least focus at least till Kubernetes installation and configuration high availability. And once you are probably around 60 to 70% inside the program, once you've done 70% of the program, and if you're looking for a job, start preparing at that time. 60 to 70% is the right time. Maybe in couple, maybe I think 6 weeks later, you start preparing for the jobs. So for that reason, we have a sample CV. We also have interview questions being asked from different years of experience as well. Someone fresher 2 years, 4 years, 8 years, 12 years, and more. So that is where you will see the sample questions. It's module 14, which is towards end of the all the modules. There will be also sample CV, but don't pick CV as it is. Change CV. This is just to give you a template on what you can do, but make sure you focus and change. Also, make sure that you update your CV based on the job description. Every job description should have a new CV in my view. So focus on first page, how you can help or that customer uh, in terms of what their requirements are, how you're meeting their requirements. So for that, this is a sample exam CV, but as I said, use this as a template and focus on things that you have done with that. So also there'll be interview questions, as I said. So go through those interview questions. Anything where if you have given interviews and you think we were not aware of any questions, or you would like to share those questions with us, we would love to hear that feedback. So drop an email to support@k20academy.com so we can incorporate those interview questions as well. Now, similarly, we have sample CV and interview questions will be same for CK and CKAD because we've incorporated a lot, but there'll be some exam interview questions we focus and say these are developer related, specific to developer. If you're coming from developer background, but CV might or sample CV will be different for developer, slight different basically. Now, if you look at the training program, um, I'm not going to go in detail right now, but we're going to keep it. I want to keep it high level. Everything that you need to do for Docker, be it Docker basics, architecture, network, storage, networking concepts, then Kubernetes architecture, deployment, high availability, disaster recovery, node affinity, and some part of basic security like role-based access control, a basic security will be covered in CKA. And then once this theory part is done and practicals are done, there'll be extensive hands-on lab. We are going to do hands-on lab as well. Same thing for Kubernetes. Now, Kubernetes, a lot of guys, we got feedback saying that what more we can do because there will be some percentage common. So for application developer, we've added 2 more topics which will be helpful for which I'm going to tell you a little bit now. And this is based on the feedback that we got from the previous batch student. So we are adding service mesh and envoy or Istio, sorry, service mesh and Istio. We'll be adding that. We'll talk about that as well. So this is comprehensive day-wise. So there'll be those who are part of CK and CKAD. We are covering initial part will be common, and then there'll be something specific to CK and something specific to CKAD. And then later, this is the additional thing we have done based on the feedback from CKAD guys, what they're doing on the job. So we'll be talking about Istio and service mesh, and then service traffic management, securing communication with mutual TLS. Some part will be available in CKS as well, this part, certified Kubernetes security. And then how do you observe the service network? So these 2 days we have added extra for CKAD guys, and those who were part of earlier, they can come back as well. So this is session schedule. Day-wise, we'll be talking about, we'll be sharing these slides, so nothing to, not to remember anything. You'll be given this entire chart, and we'll be also, in your case, we'll be putting a date as well on which day we are doing what. Now, we are trying to aim to stick to this schedule, but for some reason, if we have more questions or something happened on a particular day, if we can't complete that particular on that day, there might be 1 or 2 days extra here. If required, we'll do that. From the training point of view, we never rush anything. At the same time, we also make sure that we don't go too slow. So we keep it balanced. But if we need more time, don't worry about it. You will give more time. One thing I want to assure you is that we will never finish training with you unless you are comfortable and unless you get 2 things. One is certification and second is job. Now, for those who have not seen, we covered this in welcome video, but I'll quickly explain one more time here. Every one of you should have received a welcome email, and make sure that you join WhatsApp group. Now, if you're part of one training, CK, you join CK group. If you're part of CKAD, you join CKAD. If you're part of both, you join 2 groups. And if you're part of 3, CK, CKD, CKs, you should be joining 3 groups as well. And for CK, Certified Kubernetes Security, we'll be doing our first batch because we were busy preparing all the material. Everything is available on the portal for CK, Certified Kubernetes Security, which is the activity guide and the presentation material. So as soon as CK finishes, we'll be doing CKS immediately after that. Now this is how it looks like on portal. So for CK, there'll be two programs or two courses you will see, which is this is live. So recording of all the previous batches and current batch will be visible here, which is you can go to URL ketoneacademy.com/Kubernetes live. And you need to be logged in order to access this page first. Similarly, you can go to self-study, which means Kubernetes ketoneacademy.com/Kubernetes self. Um, Okay, so once you go, similarly for you will see two programs or two sessions for Kubernetes application developer, CKAD live and CKAD. This is where you will have well done videos. As I said, some part will be common in between CK and CKAD, but there'll be some extra as well. And as I said, from an extra point of view, we are adding more on, oh, sorry, we'll be adding more topics which will be coming up for you. Similarly, there'll be for CKS. CKS live sessions will be started when we start this batch. You will be having currently the CKS here, CKS, all the videos and labs. And depending on depending on how many, whether you bought one only or you bought in combo two or all three, you will have, depending on that many sessions you will have. Now, inside the program, you will have the similar structure. This is for, you're talking about self-study. So in self-study, you will have presentation. All the presentations we'll be sharing here at the top, each module. So this is broken down to module one. You will have presentation. These are the well-done videos, and I highly recommend you to go through the videos before you come to the class. If you really want to learn and get best out of this training, then best way is to, I think there's someone who's echo, Piyush. Okay, let's try. That's fine. Thanks. So this is where you will have lessons, well-done videos, as well as hands-on guides. So we see activity guide. These are the PDF guides, and there'll be videos as well to support this. Similarly, we'll have for CKAD, and there'll be preparation questions. Now, a lot of guys at the time of exam or when they're ready to give the exam, they ask for this. So this will be module 12 on CK sample questions. And then module 13 is about, once you have done all the preparation, there'll be mock exam questions. And below that, there'll be exam preparation where we'll talk about how to prepare for this exam, CK and CKAD. And then some of the guys who have cleared the certification, they have shared their notes, and those things are available here on the portal for you. Similarly, this is for CKAD exam. Now, depending on when did you register for the program, those who registered for the program during the live class, during the live free class, you would have received all the bonuses. And depending on, you may get one or two or all of these 6 bonuses, depending on when you bought it. So but everyone should have Linux for beginners. It's very important, especially for those who are not from Linux background. I highly recommend you to do this Linux for beginners back this, especially the chapter number 5 or lesson number 5, which is basic Linux commands, and then VI editor, permissions, and how do you copy file. Ignore this create AWS free trial because we are going to do all of this in Azure. If you want to do on AWS, you can try on AWS. We have given this procedure here. But then we also have bonus networking. Couple of guys in past said, hey, I'm not clear with what is basic networking, where we have taken a program from our other cloud course and put in what is IPv4, IPv6, CIDR representation, because when you're going to create network, you're going to create with a CIDR, and public private IP, what is VNet and subnet. For some reason, if you don't understand, don't worry about it. You can ask questions inside the WhatsApp group. Then there'll be a Kubernetes, Docker and Kubernetes on AWS. There'll be Docker and Kubernetes on AKS, which is Kubernetes. And there'll be Docker and Kubernetes on Oracle Cloud. And then this is very important, bonus number 6, which is DevOps, CI/CD using Git and Jenkins on Docker and Kubernetes on Azure Cloud. So this last one is important as well. Apart from, all are important, all are good, all will help you in job, but this one is separate because it comes under DevOps. Apart from that, depending on when did you join, I think we have started, a lot of guys when they're going for a job, they're asking DevOps concepts. So we have a separate program for DevOps fundamentals, or DevOps for beginners. So we are giving that as well bonus. So there that might be overlap with you. So I would, if you see the sessions, if you have time, you can attend that. But the DevOps sessions we have regularly. So don't worry if you miss them. Maybe a couple of months later they'll come again. So you can join that DevOps. And DevOps will cover things like basic concepts of deployment model, development model, um, development lifecycle, DevOps tools like Git, Jenkins, Ansible, basics about as well. So its program is comprehensive. Once you're in, we are not just doing one training, we are empowering you for certification and job. So this is all bonus modules. Like similar to that, there'll be some bonus modules on CKAD as well. Now, getting support, how you can make best out of this, you have two ways, WhatsApp and ticketing system. So I hope each one of you are in WhatsApp group, and we have different groups depending on in which month you joined. So depending on whatever month you see, you will be seeing group as YYMM. So it's 21, which means year 21, 01 is January. Now, those who have completed the training, we are also welcoming you to come and join the program. So for those who are from previous batches, we have moved you from that WhatsApp group onto alumni because we have a lot of audiences and we bring them into one single group, alumni group. So once your program is over, we'll move you to alumni group with others from the previous batches so that you can see and get experience from them. Apart from that, if for some reason, if your question is not responded quickly, you can then drop an email to support@k1academy.com. So when you drop an email to support@k1academy.com, it will create a ticket number. Use this WhatsApp group only for technical discussions. Apart from that, if you need any help, like, oh, your login is not working, or you need some, your bonus is not visible, or you're not clear, something that can be quickly answered, you ask in WhatsApp group. Otherwise, use support@k1academy.com. When you drop an email to support@k1academy.com, it will open a ticket number. So drop a ticket or give me the ticket number. If you need any help, we'll be progressing on ticket. Our support working hours are Monday to Friday, and I think it's 10 a.m. to 5 p.m. IST, India Standard Time. But someone else will be available if you need a little bit more support later. If it's urgent, don't worry. Um, Guys, can you go on mute? Thank you. So if you need no, so if you need something is urgent, post in WhatsApp group with a ticket number so we can help. Now, perk, you have lifetime access. So all of you have lifetime access, so nothing to worry about. You have unlimited retake over the next 1 year to program. You can come back again for the live, again over the next 1 year, so entire 2021. On top of that, we'll be supporting you over the next 1 year for job. So if anything you need in terms of job, any questions, you're implementing something on job, you can ask us, and there'll be WhatsApp group support for you. Guys, can I request everyone to go on mute, please, and unmute if you need. Later at each logical point, we'll be giving an opportunity. Now, apart from that, feedback and referrals are feedback is very important. I hope you have filled feedback form, and if not, I'll request everyone to go on to k1academy.com/QA question answer. This is around 7 questions. Do it after the class, 6 or 7 questions, which will help us to understand a little bit more about you and what we can do to make this experience better, and what your background is, and do more and more, because we got feedback. Some guys were asking about Istio, and like that we did, and there are a couple of feedbacks are coming on Prometheus and Helm, and we are working on those Prometheus and Helm and other things as well, the things that are coming and growing in market for job. Now, if you are happy, which you should be, if you're not happy, come and speak to me. If you're happy, I would love you to give the feedback on Facebook, which is k1academy.com/review of, or k1academy.com/review G. We are proud to say we have around 4.6 or 4.7 rating on Google, based on 300 plus feedback. So we're doing something good, and would love you to help us. So to help you, the more people come to the program, the more and more value we can add and give you a lot of other bonuses based on the request people get. So thank you for everyone, those who have given a good feedback as well. Now, these feedbacks are important, and you can win some draw. And every 3 months, we do lucky draw randomly and where we pick 3 winners, where you get $100, $50, and $25 every month, every 3 months, sorry. And three winners. These are some of the guys who have won these on last quarter. Next quarter will be in uh, April 1st week of April, and we'll be announcing new winners. We'll announce once it comes as well. So these are some of the guys who have win these in past. Now, also, uh, if you like session, which you will, and we because we provide a lot of value and we go above and beyond, which is possible, we'll do everything possible in our remit to make sure you get success. And if you like, I would request you to refer us to others, and just to say thank you, you'll be getting $100 cash back, money back, or you can get a $200 credit, which you can use in any other course in future. Or if you refer to three other guys of the CK or CKAD or CK, yeah, any of these courses, you'll be getting your course absolutely free. This is just to say thank you for and again, if I'm confident that you'll definitely be happy about it. You'll get result, whatever result you came, whether it's for certification or for job or for both, you'll definitely get it for that. And if you do, please refer us as well. Now, questions. Now, some of guys asked us and said, "Oh, that since we started, a lot of guys were asking about that. Can you do some doubt removal sessions, or can you do some sessions on weekday as well?" So, on top of weekend, which is Saturday and Sunday, we're also doing a session on Tuesday and Thursday, 6 oh sorry 2 p.m. to 5 p.m. GMT. So currently it's 6 a.m. to 9 a.m. PST, and you're more than happy to more than welcome to come and join these sessions Tuesday and Thursday. Tuesday and Thursday session or weekday session is a little bit ahead. We have just finished Kubernetes architecture, or maybe about to finish architecture, and then we'll be doing deployment, other things. And you can also do weekend. And you can do both as well. You can do weekend and weekday both if you want, whatever works for you. My objective is to you to consume content and get certified, and so that I can add you in our success stories as well. So get a job or whatever way works for you. So there'll be weekdays classes and weekend. Now weekday we might remove in future, so I don't want to commit, but weekends will continue to run. But looking at the demand, there's a huge demand, and we are more and more students are joining, and the more we join, the more bonuses we can give you, like the way we have done in past. So this is like more than happy to come on weekday as well. We'll publish those details on WhatsApp group as well. And with that, I'm going to open up some questions, and then I'll hand it over to Ramesh. I forgot that to mention, and I think there might be a slide for Ramesh. He is first of all, a lot of experience under his belt on Docker, Kubernetes, and not just Docker and Kubernetes, but also on Prometheus, Helm, and other advanced service mesh. He's going to cover service mesh as well. But on top of that, there's something called as enterprise Kubernetes, which is OpenShift, which is heavily used in telecom and banking. So he also works on OpenShift. So if you have any questions, OpenShift, we can take it after the class related to OpenShift. Now, the best thing I like on Ramesh is he does a lot of hands-on, and he'll teach in a style which is very simple and easy to grasp, and each has a logic what we are doing. So he will first do it in front of you on the class and show you how things are done and why that particular thing is working. So for example, Kubernetes, sorry, Docker, we're bringing an image why it's going to Docker Hub and not to some other repository, or where exactly this configuration is, or when I'm starting the container, where exactly it's picking this configuration file for me as well. So he will tell you a lot of behind the scene in very simple terms, which are easy to grasp and easy to consume as well. So first module is a little bit theory because we want to give you some background, and then we'll start with the actual practical, which will be Docker. Now, practicals, while we are on this discussion on topic, or we'll come to the practicals when we come to that point. I don't want to wait for anything longer. So with that, I'm going to hand it over to Rakesh, over to you. Ramesh, sorry, I keep mixing Ramesh. I have my cousin who's Rakesh, and we had a free class, and I kept mixing up on that time as well. So sorry for that, Ramesh. Extremely sorry. Um, so Ramesh, over to you. Um, you there, Ramesh?
Yeah,
Brilliant.
yeah, Atul,
I'm
thank you
extremely
very
sorry,
much.
Ramesh. I keep mixing up. I have a cousin and who's Rakesh, and name looks so familiar, and I'm sorry for that. And I think in the free class, I mixed up as well a couple of times. So sorry for that.
It's
With
okay,
that,
not
guys,
an issue.
let me see if there's any other question, and I'll be so Do we have recorded sessions as a bonus as well? Yes, there'll be recorded sessions as a bonus as well. And let me pick up those questions while Ramesh is sorting out. Um, okay, Kalyan is saying CKD applicable to which background? Java developer. Yeah, so CKD will be applicable for any developer, whether it's Java, .NET, Python, PHP, anything kind of a development it will be. And it will also be applicable if you're becoming architect or cloud native or Kubernetes architect, then also it will be helpful for you, Kalyan, for that. Uh, Admin can do the absolutely. If you're moving towards architect line, yes. And I would also highly recommend you for CKS Kalyan if you have not picked up CKS, Kubernetes security, because there's a lot of money onto security, which I see coming. Okay, so Piyush has already answered. Thanks, Piyush, for that. Um, Mahankali is Istio and service mesh, why it comes under CKSD, CKAD. Mahankali, that's a good question. Why they come under CKD, I have no idea. So because we got a feedback on that saying people were asking CKD, we wanted to do more, and we added Istio and service mesh. Because there's networking and other things, but the good question. I can't answer. I wanted to give something more than what's already there, and that's why we have added Istio and service mesh. Can you open those sessions to CK and CKS? I'll see that, Mankali. I don't want to commit right now. Um, I don't want to commit right now. Let me see how it goes on CK and CKS. Yeah, Mahakali. Similarly, Prometheus and Helm, is it part of CK? No, not currently. So currently Prometheus and Helm are not. We are working on preparing, and we might add bonuses. If you consume all the content, and if you see, what I don't want is, I don't want to overwhelm you with 100 things where you are unable to finish anything. If people are consuming the content, um, if you are consuming the content, if you see, I see you complete all the labs of Docker, Kubernetes, get certification, I'll be happy to open up Helm and Prometheus as well. Yeah. Um, Also, Lenovo is saying, can we also get PPT on a daily basis to topics completed? Lenovo PPTs are already there in the program for you on. If we modify, then yes, we'll update on. So as I said in the class, initially was telling you where the presentations are. PPTs are at every module on top of the module under self-study. If you can't find them, post in WhatsApp group and team will help you. Anthony is saying you told there will be a CI/CD in the CK, but I don't see anything in the outline. It's there. Okay, so CI/CD is a bonus. The outline that you see, Anthony, is all about CK exam and Docker and Kubernetes. We are going to bring this CI/CD bonuses later once people have consumed and done all the DevOps. Sorry, not DevOps. You've done all of those. What do you call? Um, Docker and Kubernetes. For CI/CD, we are doing another class from another instructor, which is who is a DevOps expert. In that, we are covering not only CI/CD using mm, oh, sorry, not. So we are doing CI/CD in the DevOps, and we will invite you for that over. So don't worry about Anthony. Everything will be coming here. So everything will be coming. This is here in the agenda. We are talking just Docker and Kubernetes. We are not talking about bonuses. Bonuses will come after we do or complete these labs and the project work. Yep. So it's coming. It will be under separately under complete DevOps program. Okay. Anuj, as I said, if I see people consuming content, if I see people are adding, we have added in CKD. I'll not take any questions right now for HTTP and service mesh. We'll come to that point. What timing will the CK session schedule? Anand, it will be once CK is over, it will be the same time, around the same time, but after the CK. Are we do hands-on lab for only Azure and any other cloud platform? No, hands-on lab. Okay, this good question. This keeps again and again. So currently we are doing hands-on lab on Azure cloud. Now, the reason being is we have tested on Azure cloud. If you want to do on AWS cloud, feel free to do it, but we have not tested on AWS cloud. We can help you if you hit any problem. Let me know. I'm planning to do these same things on AWS cloud as well, but not right now. Sudhakar and Surendra, guys, I'll pass on. I'll hold Istio. I'll park that because Istio is not part of Istio and Service Mesh. I'll park that. But we are going to cover Nginx and ingress and egress controller. We are going to cover that ingress and egress controller. how possible it is to have a portfolio on our GitHub. You can have that entry. Everything is available on our GitHub. You can have, we'll cover that as well. With that, I'll not take much time. I'm going to hand it over to, and the protocol we are going to do is that you ask all the questions in the chat window, and at each logical point, wherever Ramesh thinks are important and are required, he will stop, take all the questions, but we are not going to interrupt him in the middle every question, because then it breaks the flow. He will take a particular topic, maybe 2 or 3 topics. The reason being is there's a high probability that your question might have already been covered in the next topic, or once he finishes, you might already get your answer. So he'll take the questions at each logical point, or otherwise we'll take all the remaining questions at the end. For some reason, if your question is not answered, nothing to worry about. We pick up all the questions, we take the questions, and we give their answers and post it on the under the live session, and we'll also inform in WhatsApp group. So Piyush will take care of that, and we have 2 other teaching assistants. So Piyush is there, and there are 2 more guys with Piyush who will be helping him. So we have a lot of support as well handy for this. With that, Ramesh, I'm sorry I've taken a lot of your time. Over to you. I'll be answering the questions in the chat window behind the scene. Over to you, Ramesh.
All right, thank you, Atul. I hope I'm audible.
Yes, you are. And then just your screen is not full screen. If you want to, maybe it's purposefully, but it's not. Otherwise, it's all fine.
Okay, no problem. All right, friends. So welcome all. This is Ramesh here, and I will be there along with you for this entire journey of CKA, CKAD, and I hope I'll make sure that the journey will be enjoyable to you. Not only enjoyable, but definitely you will get more and more technical information, hands-on, so that you can use in your project as well as getting a good jobs. All right. So basically, what we are going to discuss today is something about what is the cloud computing. So most of us know about the cloud computing, right? So I don't think so that there is any person who is not knowing about the cloud computing, or they are not using a cloud computing. Today, I'm going to just put it differently, a little bit differently. What is exactly cloud computing and what are the benefits of it? We'll also discuss about the monolithic application overview. We'll also discuss why it is, what is the issue along with the monolithic application, and we'll discuss about the architecture of the same. But more focus will be on what are the microservices, what is its architecture, design, and deployment strategies. That is what we are going to see in the today's session. And after that, if we get a chance, we'll try to deploy the Docker as well, and we'll start working on as well that as well. Okay. So guys, let us discuss a little bit about what is the cloud computing. So then I will go along with the slides quickly. I just want to show you one. I would like to show you with the whiteboard. This is my whiteboard. Uh, what is the cloud computing? What is the use of the cloud basically? So people will say that yes, we use it for creating the servers on the cloud platform. We deploy the application on that one. We deploy the database on that one. Correct. So absolutely, it is true that cloud computing is nothing but accessing the somebody's infrastructure, from the on the browser on the click, right? And we are able to do that one with the help of just browser, guys. So let me just explain you what is the building block of the cloud computing. Why the cloud computing is so interesting? There is only one reason for that one, that is virtual machine, because we are able to deploy the virtual machines on the cloud, right? So guys, what we do with the virtual machines, quickly we'll see that. What is required if you want to deploy the virtual machine on the cloud? So basically, somebody say it is an instance, somebody say that a server, somebody say it is a virtual machine, but basically it is a virtual machine which is deployed on the hypervisor, and that's why the cloud is there, right? So if you want to deploy a virtual machine, what is the first thing that you need? You need one thing called as CPU and RAM. That is called as a computing power. And who do you provide this? How you can access the CPU and RAM of the servers which are placed somewhere across the globe in some data center, in some rack, in some hardware, that CPU and RAM is there, and I want to use it for my virtual machine. How do I get it? If at all, if I say that I want to access the CPU and RAM of your machine and deploy my virtual machine, it is not directly possible. We need to have some software, right? So what is that software which provides the CPU and RAM to you? We'll see that one. Then is another thing that required is a hard drive, right? This is very important from the cloud perspective. So guys, if you want to deploy the virtual machine, you need a hard drive, right?
Sorry,
Correct.
1 second, Pujita. If you can go on mute, please, Pujita, and Piyush, if you can mute Pujita.
Right. So who do provide the, again, other than this hard disk, you require one more model that is very important. That is, you require operating system. Without operating system, how you can install anything, right? After that, you need a IP address. You need a LAN card, right? You need a firewall. What else? There are so many things are required, right? So who provides this, guys? You require something called as billing, right? Metering is required. Yeah, you also access this particular virtual machine dashboard through the dashboard. So, right, so you need a dashboard for accessing this cloud computing environment. So, guys, what were all the participants and all the people who are using this AWS, Azure, or Google Cloud or IBM Cloud? We are just using them, right? But behind the scene, what exactly happens? I'm just giving you the glimpse of it, right? So CPU and RAM is provided one of the very interesting service, if you might be knowing about that. That service is called as a NOAA. Hard disk is provided by the another interesting service that is called as Cinder. It is a block storage. Operating system is provided by the another image storage service that is called as a Glance. I mean, what I am talking about all these guys. If I want to access the CPU and RAM, that is called as a T2.micro or something like that, right? In the AWS. If I want to access the 8 GB hard drive, or if I want to use 30 GB or 100 GB hard drive, who will provide me that? So there is there are the softwares behind that which are deployed on the hardware, and these softwares are making the use of or making this available to you, and that's why we are able to deploy our virtual machine. So this is a glance. Glance is nothing but it lists all the operating systems in the AWS cloud or Amazon cloud or anywhere or in Azure cloud. So you choose this, you just type that I want something called as Red Hat, I want something called as CentOS, I want to have something called as Ubuntu. And who provides that list of the images, right? That is called as a glance. Who provides you the IP address? Who provides you the LAN card? Who provides you the firewall, elastic IP address, private IP addresses, and everything? There is one service which is very interesting service that is called as Neutron. Some of you might be aware about this, guys. Just I'm giving this a glimpse of it so that it will be handy for you in future. So who do the calculation that how much CPU and RAM or how much computing power has been used by you? And that is an interesting story behind that is called as telemetry. So telemetry is the software which resides on the cloud infrastructure, which calculates that how much CPU and RAM has been utilized by you. Accordingly, they will calculate the billing so that you have to pay it monthly. And who provides the dashboard, which is the service which provides you a dashboard, guys? And that service is provided by the Horizon. Right? So there is a lot of things are there for providing the database. You have a Trove and lots of things are there. So what I'm trying to do, guys, this is the
Sorry,
basic flag.
Ramesh.
Mhm.
Sorry, Ramesh. Sorry to interrupt. If you take a screenshot of that or save these images because we need to share it with everyone. Last time I know we missed it and weekday batch. So yeah, so if you save that every time, like before you delete, if you can save them and share it with team so we can put upload in there. Yeah. And this is guys, this is something I'm also learning new, which is good thing from a cloud. We are giving above and beyond. Any doubts we'll be asking and we'll be taking up later on these topics. Over to you.
Right, thank you. So all the services which are deployed on the hardware or infrastructure of the data center, which is called as a cloud data center. So that these services are called as, or these services are come under the very interesting topic that is called as OpenStack. All right, guys. So this is something which I wanted to show you. Now this is behind the cloud, right? So if you want to study a very interesting part of the cloud, just not to learn how to use the cloud and deploy the virtual machines, try to understand how it is deployed. Try to understand how it is developed. So this is just a glimpse of it. All right, guys. I
So
hope that
sorry,
answers.
before I go further, just to add all these, if you're confused what these are, there are two type of cloud. One is called as enterprise cloud, like we have from Amazon or AWS or Google or IBM, and this is OpenStack, which is an open source, and these companies use some of these open source, put their own stamp on top of that, and then show you. So if we talk in the same way, if you look at an AWS or Azure, there are different type of storage. There is a block storage, object storage, file storage. If you're coming from a networking, you might have a network in that you have virtual IPs, LAN, firewall, metering, telemetry, all those things will be here. In the construct of cloud, it will be slightly different. Again, you don't need to know these or remember these, but it's good to understand and good to have that when you go into the market. It'll be helpful, please. So post like sorry so this is OpenStack, which is an open source cloud. Let's suppose you want to build cloud, you don't want to use Google, you don't want to use IBM, you want to build your own cloud. Like I'm a HSBC big company and I want, rather than going to cloud, I can want to build my own. That's what OpenStack you can use to build that. Now some of these clouds and some of these things we have to cover a little bit later. The reason why we are saying explaining these are, we're going to build our Kubernetes on the cloud, and also in current world you can't live without cloud. So it's good to have these knowledge. We are going to keep it short and to the point so that we can come to straight to the Docker and Kubernetes quickly, if possible today. If not, we'll have we'll see what we can do. Now questions, please don't hesitate to ask. Vinay, yes, please go ahead and ask questions. We'll be taking up questions at each
Okay,
logical point.
so,
We'll be answering.
yeah, thanks a lot, Atul. So my question is to Kishore. So just want to know, actually, I have some idea of like, like the Azure portal actually. So my question is, so when we create our subscription to Azure portal and create a virtual machine, then when we create virtual machine, then we get lot of options, right? Drop down how much memory you need, how much hard disk you need, what operating system you need, and private IP, public IP, how will be the billing and metering that you are saying, the metering actually, and firewall and all. So all those services are Azure is integrating all those integrating with these services actually to get those options in the drop down, or they have their own. Just want to know.
These are the standard methodologies used by the cloud organizations. Top of that, they have done the lot of development to bring it user interface, very comfortable user interface for you. But behind the scene, this is the source of the information for all the cloud computing.
All the cloud computing. Okay, thanks a lot for clarifying actually.
Thanks.
Thank you.
And by the way, he's not Kishore, Ramesh. I totally mix up as well. Kishore is from our DevOps, Azure DevOps. So don't worry, I totally understand. Some of you guys are coming from different courses as well, so not to worry about. And Ramesh, please don't feel offended. I'm the worst
Right.
culprit here for not remembering names. Over to you. Let's
Uh,
continue from here, guys.
yeah, sure.
Questions like these will be good to, if you can ask me in what's chat window, so I can do. Yeah. Next
All
one,
right.
please. Yeah.
Thank you. Can we? Okay. I hope that
Yeah, let's
everybody has a.
continue. And then, as I said, we'll be
Yeah.
taking questions in the chat through the chat window, because otherwise it might break the flow. And I can answer their questions quickly within the chat without interrupting the flow. Over to you,
Right.
please.
Yeah, absolutely correct. So guys, these are the organizations which use the different service models. Best of, you know about that, right? Service models, what I'm talking about. So there are 4 service models which are precisely used by the organizations. We have a very good slide for that one, but let me put it in the piece of on the whiteboard to make you understand. So first one is the on-premises. So guys, whenever you want, what is the meaning of on-premises service? On-premises service is nothing but there is to deploy any application, guys. To deploy any application, what is important thing is you require infrastructure. Middleware is that you require operating system and some platform, and top of that you deploy the application, right? So this is something which is all the people do. So if your organization is going to manage infra, if your organization is going to manage something called as a middleware or platform, and if your organization is going to manage your own application by your own hardware, infrastructure and everything, this comes under the on-premises. This is called as the on-premises data center or on-premises deployment, right? This is one of the service model many organizations are using. Another service model, it is called as infrastructure as a service. And what is infrastructure as a service, guys? Let's say this is, I'm drawing a block here, and infrastructure as a service is nothing but you are just picking up infrastructure from the cloud service provider. right? So you will be taking the infrastructure from them, but on the top of that, you will be managing your own platform as well as your own applications. So here only this particular part will be taken care by the cloud service provider. That is called as infrastructure management, right? This one. And this will be taken care by you. So I'm drawing with some other color. This will be taken by managed by you. Here everything will be managed by you. Infra, platform, as well as application. Platform is nothing but kind of operating system and other things. Okay, so this is on premises, and so this is called as infrastructure as a service. So let me write here, it is capital S. It is pronounced as infrastructure as a service. So you will be taking the infrastructure from the cloud service provider. Another is a platform as a service, right? So in that case, what you do, you take care of the infrastructure. You take the infrastructure from the cloud service provider, as well as you take the infrastructure, as well as you take the middleware or platform from the cloud infrastructure, cloud service provider. So these two things will be taken by from the cloud service provider, like this one. Let's say that, let me put it here. So this is infrastructure taken from the cloud, like CPU, RAM, hardware, and you need a platform that is operating system, some middleware section softwares which is required, you can put it over there. And then in the platform as service, you take care of your application, right? Deploying the application and everything is managed by you yourself. So this is your job. So this is taken care by you, and this is called as platform as a service. All right, friends, and there is one last model, service model has been being used, and that is called as software as a service. So everything is taken care by them, right? Infrastructure, cloud service provider, that is infrastructure also taken care by them, as well as platform also taken care by them, as well as the application deployment and everything is taken care by them. And what you are going to do, you are going to just use them. So this is taken care by, everything is taken care by the cloud service provider. This one, as well as this three part. The best example of the, and this is called as a software as a service. So you are going to use this as a service, software as a service. And the best example of this one is, you can say that if I want to give you in the different manner, the electricity which we get in our home, right, it is a service, right? We don't have to think about how the electricity is produced, how the turbine flows, how they have transmitted the electricity and everything. We just don't have to care about it. We don't have to care about it. We have to just use it and pay how much you consume it, right? That is called as a software as a service. All right, guys, so these are the four models. And so best example, nowadays we are using a lot of HR people, and a lot of HR models has been deployed on the top of the cloud service provider, and we are just using it. So best example of the SaaS or software as a service is Open 365. Okay, Office 365, sorry. So Office 365 gives you everything. They take care of infrastructure, they take care of the platform, they take care of the application. We just use it, and we just pay for what we use it. All right, guys. All right. So this is something about the
Yeah.
service model. Yeah.
So just to add two more things. So example of, you already, Ramesh already mentioned, Office 365 is an example of software as a service. You might be using Salesforce if you're using, I'm using Gmail if you're using paid version of Gmail. Like for example, we use Gmail for our company address, K20 Academy. You see support or contact, all those email addresses. They're a paid version of Gmail, which is so that we don't need to worry about infrastructure. All we need care is we get license, and we are being charged for licenses. That software as a service. Now, example of platform. Gyanendra was saying, what is platform? Example of platform is my database as a service. So I don't care. I don't manage my machines. I don't manage my operating system. I don't manage my hardware. All I get is a database. I can create the data, or I can create schemas or users and use the database. So it's a platform as a service. Now I need to take care of maybe high availability depending on what kind of a service I want, but I'm getting a platform. Similarly, I can get a platform of an application server. I might get a app platform like my WebLogic server, or might get a IIS web server. I might get a Apache as a platform. PHP link, LAMP stack, which is a Linux Apache, entire website, for example, for hosting my website, WordPress is an example of platform as a service. Now, what is example of infrastructure service? The Linux machine I create, that is an example of infrastructure service. Network I create is an example of an infrastructure service. The storage I create is an example of infrastructure service. So later in this training, we are going to create a couple of machines, Linux machines or Ubuntu machine. On that, we are going to install Docker, and that is my example of infrastructure as service. But later we are going to also deploy Azure Kubernetes service, which is Kubernetes running on Azure cloud. That is actually an example of platform as a service, because where I'm getting a platform built on cloud. But if I'm picking up a machines on my own, 3 machines and storage and networking, and then install Kubernetes on top of that manually using Kubernetes, that's an example of infrastructure as service. Whereas platform as a service example is my web apps. If you are coming from Azure training background, or if you're coming from AWS Elastic Beanstalk, is an example of platform as a service. Docker, which is ECS, Elastic Container Service, Azure Container Instances, Azure Kubernetes Service. These are all example of platform as a service or database cloud service. I hope that makes sense. Now, Anant is saying one more question and we'll move on to the next one. What considerations or restrictions companies use to infrastructure instead of PaaS, since data will remain in the company? So data will always be remain in the company for all 3. So data you manage, and it's your responsibility to manage the data. In infrastructure as a service, platform as a service, and software as a service, your data will be your own. They will not be able to see your data unless you give them access yourself. They will not be able to see your data. Now, if you want the data to be restricted or kept within your data center, then there's something called as cloud at customer. Again, I don't want to go too much into cloud. This is just to give you an eye level overview. But if you want to restrict to use IS instead of PaaS, you don't take their platform as a service. Anand, I'm going to discuss this outside in our WhatsApp group if you need any further question on that discussion. Let's move on. Over to you, Ramesh. Anand, we'll discuss any questions. We'll post in WhatsApp group and we'll discuss there. Yeah. Over to you.
All right, thank you very much.
Ramesh, don't forget to save it. Like, these are good drawings, and of course, guys, what the teaching style, and that's why I love is we don't want to read you from the slide, because we've already done. Wherever required, we'll read you or walk you through. But don't worry that, oh, it's point by point. Some guys in past gave a feedback, oh, you're not covering everything covered in the slide. It's already there. Everything what we have covered in the slide is already there on the videos for you. We're giving a different thing, and we are not going to leave anything from the program. So don't worry. Don't feel that. Our intention is to give above and beyond and more than what's already there in the program, so that you get different views and different ways to learn. Yep. I hope that, yeah, let's continue from here, Ramesh. And I want to come on to the Dockers sooner than, but these are important
Right.
topics. No, these are good topics.
Yeah, sure. I will make sure that one will, and also I will walk through that presentation, guys. Don't worry about it.
Sorry,
So
while we are on this, very quickly, I'll explain as well by going to the console here, or let's continue from here. I don't want to interrupt you. We'll cover that. We'll show the console and everything. So don't worry, guys. We are going to give you the access of Azure Cloud and possibly AWS Cloud if you feel more comfortable with AWS Cloud. But as I said, do it on your own risk. We have given you both the options. Azure will be our preferred choice as well. Over to you.
right, thank you. So what are the benefits of the cloud which we have? See, everything is there in the slide, guys. I'm just putting in the words, and once we complete this discussion, we'll go into the slides, and then you will be able to pick up it in the standard way. Don't worry about that. So what are the benefits of the cloud computing? Why do people go there? What is the need of it? We were happy on the data center on premises, where people were used to deploy their applications on the in the data centers. They used to have their own data centers, right? So what is the difference cloud has made with us, right? Or all the enterprise organization. One thing is that no capex. What is the meaning of no capex?
Sorry, Ramesh,
Yeah.
sorry to bother you again. Is it possible to close this Jira pop-up which is coming, which is no,
Not now.
yeah, if you
I'll
close
just.
on no problem. No, we'll take it next time.
Yeah.
Let's work out the next time how to do that to cancel this. Okay, we'll pick it
Right.
next
I
time.
will try.
Sorry,
Yeah, sure.
Gyanendra. Yeah,
Yeah.
over to you.
Yeah. Thank you. So this is something called as a capex, right? So capex is not required. Earlier, if any customer comes to you and says that I would like to develop some software with along with you, your organization, first thing comes in mind that how much capex will be required, how many servers will be required. Now, because of the cloud computing, we don't indulge into the capex. No capital investment required. That is the beauty of it. It is zero capital investment. This is one thing, right? Second thing, what comes in your mind, guys? What is the second beautiful advantage of the cloud computing is something called as pay as you use. This is very interesting, right? So if on 31st March or when the financial year is closing, that day you require a lot of CPU and RAM, right? This is a normal scenario in the various banks and banking sectors. I have seen that they will require a lot of CPU and RAM on that day. So for only for one day, should I buy the infrastructure which is heavily configured, and rest of the time we are not using it, right? So this is the beauty of it. I want only more configuration on the 31st March or maybe on the financial year closure. I will just buy the hardware for that one. Yeah, please mute, guys. This is a little bit background noise coming. Okay.
Yeah,
Thing.
guys, again, sorry to interrupt. Piyush, if you notice anything, who's unmuted, can you mute them as well? And Piyush, bring one more person to manage with you so they can help you. Piyush, over to you, Ramesh.
Right. Yeah, so this is another very important and interesting advantage of it, right? Pay as you use, right? So you don't have to worry about it. Third important thing is that lead time. Lead time is a important thing, important from the business point of view. How much time normally earlier it used to take? When I say earlier, that means at least 10 years back, when I was to used to handle the various software development and data center teams. That time I know that when if any customer comes and say that, look, we would like to do the business with you, so then we start procuring the hardware, and that hardware takes at least 6 weeks time to come, and then configuration and putting it to the rack and stack it and then power on and then give the IP address to the developer. It used to take 8 weeks of time, at least minimum 6 to 8 weeks of time. Now that lead time has been reduced significantly. If I want to create an infrastructure on the cloud, it just takes, can be 2 minutes or maybe maximum 5 minutes. Once I decide that what hardware I want to procure, it will be immediately taken. So it has been tremendously lowered down, right? So this is another beneficial of the cloud computing. And of course, this is secure. Nowadays, security has been taken care by the cloud organizations like anything. You have a very good firewall configuration and everything, which is put into place, as well as some of the organizations, some of the cloud service providers provide the federal services for the keeping the data of the government organizations inside their country. So that comes as a federal benefits are given by, because some policies of some countries policies are there, you cannot put the data outside the country. For that, some of the cloud organization has come with the federal options. So these are the beautiful options and very important options, advantages of the cloud computing companies. And another very important thing which I forgot to tell you guys, that is you can do horizontal scaling as well as vertical scaling. So if your CPU utilization is going more than 70, what is the horizontal scaling? Horizontal scaling is nothing but if your CPU utilization is going more than 70% or maybe 80%, right, guys, you can add more amount of machines, right? Virtual machines. You can add one more, like that one. And what is the vertical scaling? Vertical scaling is nothing but making that particular machine strong, that is increasing CPU and memory. So that is nothing but vertical. So that we can do whenever you want it, right, guys? These are some of the beautiful advantages of the benefits of the cloud computing organizations. I hope that this is clear to all of you. All right, so you can see now, let me just take you to the now some of the slides which are there. Okay, guys, so these are the models that we are going to look into it. And so what are the evolution of development and deployment has happened? So earlier when earlier in the, let's say 20 decades to 2 decades back, people used to have the waterfall method, right? And what is the waterfall method? That customer used to come and they give the all the requirements, and uh, software guy used to develop that. And once that development is completed, then customer will come to see that what is my product. So that was having some advantages as well as some disadvantages, but we don't want to go inside that one. what are the advantages of waterfall and disadvantages of it. Everybody is aware about it. But it is a monolithic, which is a little bit worrisome. Okay, monolithic is nothing but having all the applications inside one box or running inside one, let's say, model. So that was the issue, that keeping all the application models in one basket was making a life difficult that time. So that was a difficult scenario whenever you want to, let's say you have one application with 4 to 5 different models are there, and you want to do something called as upgradation or change in the code. So slowly that application used to become a bulky, and there were a lot of issues to solve that one, right? So this was, we have some slide for showing you how the monolithic application look like. And that time you need to have the physical server, and you have to have that put into the data center. That was a scenario in early decades, right? Couple of decades back. But after that, what is started, there is a new terminology come as called as agile. So software development cycles has been broken down in the weeks time, right? 2 weeks time or 4 weeks of time. And then they have come up with a different architecture style called as the entire. So then that time, many of you might be using this particular fundamentals, the entire fundamentals, that you have web server, you have application server, you have database servers, right? And nowadays, in that era of 2000, virtual servers have started coming up, and people have started deploying these softwares, different applications, like different tiers, like application on one virtual machine, then database on another virtual machine, or web on the another virtual machine. And that scenario was called as hosted, right? So hosted scenario, so people used to have the different virtual machines on one physical hardware, and like that one. So it was really, agile methodology is absolutely fantastic methodology which has happened in the software industry right now. Because of that, customer can see their product before it, what exactly is going on. They understand, rather than losing the interest later on. They can tell you what are the changes need to be made when it is agile methodology. So DevOps has picked up that fantastic methodology of the software development called as agile, and they have put it into the DevOps as well, you can say. But more or less, they have tried to remove the lot of wastage which were happening in the DevOps in the earlier versions of waterfall and agile, like waiting wastage is there, or there is a lot of rotation wastage is there. A lot of wastages are happened in the software development life cycle. I think DevOps fundamentals consist all that. What are the wastage and what are the advantages of the DevOps? So DevOps makes your life very easy. And in this scenario, what has happened? Everything has been converted into the microservices. So the difference between monolithic and microservices is, um, okay, okay, all right. I hope that now it is stopped. Thank you. So micro DevOps has given the birth to the microservices, you can say. So now I don't have to keep my different models of one application in one box. Right now we can put them into the small computers, some small servers called as a containers, right? And you can deploy these small PCs or small computers called as containers. We can deploy the applications in these containers, and you can ship it wherever you want to. What is meaning of shipping? Shipping is nothing but like putting it on the development machine, putting on the testing machine, UAT machine, pre-production machine, production machine. So that makes the life easier if you have microservices. We have one slide for detailed explanation about the microservices. Okay, now, so this is the era of the containerization, guys, and we cannot avoid this era, right? And this is a beautiful thing happened to the world in the IT industry when somebody called in 2013, somebody has come up with the concept called as a Docker, right? And this is something which is really fantastic. And normally we can have the containers on the cloud. That is a preferred way, but you can deploy on your desktop machines, laptop, as well as your on-premises server as well, right? So this is something called as evolution of development and deployment. Let's move ahead and discuss something about we have discussed about this, what is the pain on premises of premises. You have to think about about the capex. You have to put a lot of racks, infrastructure, power, cooling, and everything. That is actually pain, right? A lot of capex was involved in that one. right? You need to think about the lot of cabling used to happen. So passive cabling, then you have to think about the what happens if natural calamity happens, such as rain, there's some disaster happens, then what you are going to do with your data. Okay, so you have to take care of that one, as well as that time there was the issue about the vertical scaling and horizontal scaling. If I want to add some CPU and RAM, then we have to remove that box and add some CPU and RAM and then change it. That was really tough. So that is actually pain of on premises, right? This is something about what I have just shown you in the one diagram, that what are the disadvantages of the on-premises thing, right? And these are the basically advantages of the cloud computing. This is all removed from that. You can do the vertical scaling as well as horizontal scaling. All right, so this is something called as, it is shown in the different diagram. The way this diagram is there, the same way this another diagram is there, guys. This is evolution of IT. Right, you can see in the detail that there is a waterfall model, then agile has come, and this DevOps is going on. Waterfall model used to have the monolithic, it used to use the physical servers which were placed in the data centers. Now from the customer point of view, in the agile methodology, they have created they have divided the one monolithic application in the multiple tiers, such as web tier, application tier, and database tier, and that was deployed on the virtual boxes, and it's called as a hosting terminology. It is called as a hosted services. And now in the DevOps scenario, now in this era, what is happening? Many people are using the cloud to deploy their microservices inside the container, right? So this is something which is really happen, and we are just seeing this right now. We are looking into this particular thing, right? And we are happy that we as an administrator or as a network engineer or as a developer, we have seen at least all of them. Some of you might be in the middle, this agile and DevOps, but we have seen, personally I have seen all these three pages. Okay, good. Okay, so this is something called as, what is the definition of cloud computing? So cloud computing can be referred as the remote allocation of resources on the cloud. It is on demand and you have to do it self-service. Nobody will do work for you. You have to do yourself. You have there is no problem of the network access. Resource pooling is good thing, that whenever you want the resources, you can pull it from the cloud. That is what the services I told you. You want more CPU, you want more RAM. There are no service which is running behind that, and that will be helpful to you. And another thing is the elasticity, that you, whenever you want to increase, you can increase it. When you want to decrease that resources, you can decrease also. And very important thing is a pay per use, right? So whenever you use the hardware resources, you pay it. If you don't want, you reduce it and pay the less amount. So these are the, we have discussed about what are the benefits of the cloud, that is management effort, ease of use, fault resilient, scalable, reduce cost, services options, and a lot of things are there, which was I have discussed earlier, guys. And cloud services provide you the virtual machines, and that is a building block of it. If virtualization is not the concept there, then cloud services might have got dropped. So this is, yeah, please mute yourself. Please mute yourself. Yeah. Container as a service, right? This is a new thing which has happened, and we are going to discuss about this database as a service, where we can deploy SQL, no SQL, networking, everything. This is software defined, guys. Networking, storage, whenever you want block, whenever you want to object storage, you will get it, right? So this is what services. There are plenty of services, and you might be knowing that one. So if you open the cloud service providers, this one, and you'll see the lot of services running there. Okay, cool. And this is what we have discussed. What is infrastructure as a service, platform as a service, as well as software as a service, and as well as on premises. And I have told you, discussed with that, what is on premises. Everything is taken care by you, right? In infrastructure as a service, look, this is taken by the platform. Infrastructure as a service, infrastructure will be provided by the organization, cloud service provider, and you have to manage the operating system and middleware, as well as the applications over there. In the platform as a service, the infrastructure provider, that is cloud service provider, will take the infrastructure as well as middleware, that is a platform, and you have to manage your application. And as in software as service, as discussed earlier, everything will be taken care by the cloud service provider. We have to just use it, right? So these are the service models which you have discussed some time back. I hope that now this is clear picture in front of you. Okay. Now, so these are some of the examples which you have given. What is infrastructure as a service? Who provides this infrastructure to you? There are various cloud service provider organizations which provides this infrastructure. Who are there as a platform as a service? So this is something called as a Google app or some Apache stack. OpenShift is there, AWS Elastic Beanstalk is there. A lot of things are there we can use as a databases are there. You can use that as a platform as a service. And what is software as a service? You just use the software which is coming out of that infrastructure, right? As a Google Apps, right? Dropbox, or maybe Open 365, and right? That all that software comes as the software as a service. All right. So yeah. So before going to monolithic, I hope that everything is taken care by. If there are any questions or something like that, you can ask. Otherwise, we'll move ahead with the monolithic overview. Okay. All right. How is the persistence of DB maintained, since it is pay as used? I have to pay for DB server 24/7. If you are using 24/7 like databases, if you are using the CPU and RAM utilizations continuously, you have to pay as per your use, right? Yes, you can opt for the hybrid services as well. Like you can keep your application, or you can keep your database over there, and you can keep your half part of the services on your on-premises. You can use that kind of combination. So if you feel that your database is very important, data is very important, create a database systems on the on-premises and not in the application. So right, so you can use both. You can use combination of them. So many people do like that one. They keep the application on this AWS or Azure cloud, and they keep their databases on premises, or maybe backup services in the premises, like that. Okay, so let's move ahead, guys. What is a monolithic overview? Monolithic overview is nothing but putting all the, in one word. I use one word always, that one sentence to explain you. Putting all the eggs in one basket is nothing but monolithic application. So it has all of its components residing together as a one unit, right? So web application is a software program running on a web server, or an application consists of three main components such as user interface or databases or server, right? All that things comes as application, and all three of these components are in one unit, written as a and released as a single unit, right? So that is nothing but a monolithic, everything in one piece. Okay, so has some problems. There are some issues with this application, this kind of architecture. So you have a business logic, then there is a database, and this is the application put together. It is built or it is configured in such a way that it will be released as a one package, and it will be deployed in one server. So that becomes your monolithic architecture. So what are the disadvantages of this monolithic application? So of course, right, when you increase the line of code, when complexity increases, the line of code also increases, so it becomes bulky. So whenever you want to do the upgrade or make important changes, it becomes harder to do that. So developer needs to test any change they are working on and test the entire system. This is also an important thing, that is the problem of the monolithic architecture, right? It can be it becomes very difficult to adapt to the new technologies, because a lot of things are written in one application, and they are running smoothly on one hardware. And if suddenly new technology come, and if you want to move that one, it becomes very, in fact, moving from one version to another version is a challenging thing in the monolithic application. We don't know which piece of this particular package will get dropped or will not be compatible. So that is a really difficult situation when in the monolithic environment. Takes deploy as a longer. Of course, it takes a lot of time to deploy as well. So this is what the disadvantage of the monolithic architecture or monolithic. Okay, so what is the architecture actually? You can see this diagram, and I think from this diagram you will understand what I was trying to say. That all the models of the, let's say this is one passenger company who is used to transport the people from one place to another place, right? And in their application, they have a monolithic architecture. They have created the monolithic architecture and they have deployed their application. And all the models of passenger management, right? Then the payments, notifications, billing, trip management, driver management, all these small models, or maybe bigger models, are put together in one package and it has been deployed on one server, right? And then this becomes difficult if you want, let's say if one billing model goes down, then and it brings down the entire stuff. If payment model goes down, then it brings down the entire stuff, and then you have to fix up entire system, and then you have to bring up the application again. So it takes a lot of time to troubleshoot if something goes wrong with some system, right? Some model you have to troubleshoot from A to Z. Okay, so that's why monolithic architecture is somehow it becomes difficult to manage if there is a lot of complex architecture or complex applications are there. But of course, for the small applications, it doesn't make any that much difference. Okay, so I hope that this is monolithic architecture diagram. So these are some of the effects you see. Size of the application will also slow down development. Of course, the larger the application, the longer the startup time is. It takes a lot of time to start, maybe 15 minutes, 20 minutes it will take to start your application. That much downtime you have to incur. It is an obstacle to continuous deployment, right? So there is no point of the CI/CD if it is a monolithic kind of application, right? So if it is a large application, then you have to take care of it properly. Extension testing is required. You cannot just deploy the application like that, right? You have to do the testing and you have to check whether what is impacting what. And if everything is smooth, then only will. So it was a really challenging time earlier than when there was a monolithic application stuff. People are still using it. Monolithic application can also be difficult to scale when different models have conflicting resource requirements. So this is what I was talking about, that dependency, maybe a software dependency, maybe a hardware dependency, right? If you try to upgrade that one, if you try to downgrade that one, if you try to adopt the new technology, so you have to think twice, think thrice before deploying, before adopting the new technology in the monolithic application. Extremely difficult to adapt new frameworks and languages. This is what, so when I was trying to, let's say if you have the application written in the PHP, let's say 6.2 or 7. If you want to migrate to the 7 version of the PHP, you are not sure whether it will work fine or not. You have to do a lot of testing. So that is the only, that was the issue with this particular kind of architecture. Okay, now, so what is the solution for this? What comes in mind here, right? So it is better that don't put your all eggs in one basket. That is one solution there. But how to do that? So the solution for the monolith architecture is something called as microservices. So define an architecture that structure the application as set of loosely coupled collaborating services. So small services. You break the application in the small services, interdependent or dependent services, but make sure that they are loosely coupled. They are dependent, but they are loosely coupled. So you can just take one services out of it and you can repair it and you can bring it back, right? That kind of modular kind of thing, that is the solution for this. Each service should be highly maintainable and testable, loosely coupled with other services. This is what I was talking, and independently deployable. It is similar like that nowadays. If one server is there, and if you see the servers in the big cloud service providers, you will find that everything is a modular. If my CPU goes down, I just replace the CPU model or my motherboard completely, right? So there are the dependent servers, there are the redundant servers, and that is called as a fault tolerant servers. Everything is independent. Every model can be repaired or replaced, right? So servers are also now working as a hardware level. They are also microservices now. Okay, capable of being developed by a small team. That's fine. This is a solution that is, I think, for the microservices, for the monolithic, and that is called as a microservices. So what comes in your mind when we say microservices? So microservices is the structure, it is style, it is architecture style. So that an application as a collection of various services, right? So it collects different services and it put together and put on the different servers also. Split the application into set of smaller interconnected services. Okay, and typically what happens, what is a service? A service typically implements a set of distinct features or functionalities such as order management and customer management. So we have seen in the one of the example in the monolithic application, right? That your payment management system or your customer management system or trip management system can be considered as a different service. And each service gives a different functions and features, right? So each microservice is a mini application that has its own hexagonal architecture consisting of business logic with various adapters, right? So this is something about the microservices, and we'll just move on with the architecture of it and see. Now everything is divided into small pieces, right? Small services. So if my passenger management is going down or having some problem, I can just work on this one. That time this is not getting affected, right? If in the let's say peak hours, when there is a lot of passengers are calling or trips are getting called, right? You can increase the more number of containers here. You can put more number of services over there. You can have a container farm to manage this trip, right? Management team. If there are payments are happening, a lot of payments are happening in the peak hours, make sure that you have multiple containers who are serving the same thing behind the load balancer. So you can increase the one service, you can decrease it, right? So that is what you can increase the resources, you can decrease the resources for one services when there is a peak hours are going on. That is called as a horizontal scaling. If I want to do the horizontal scaling for one service, I can do it. I don't have to do for the all. That is the beauty of these microservices, right? So if something goes wrong with the driver web UI, we can just fix this issue. That time other things will work properly. But how I deploy these services and where I can deploy these services, so many servers will be required, right? And that's what containers are really helpful for, taking this one service inside them and just serving it to the customers. And they're very lightweight also. We'll see that in detail, that what are the containers and what is a container is all about, right? So this is about the microservices architecture. Let me see if you have any questions and then we'll go further. Okay. Yeah, all right. I think you have answered all the questions. Fine. Thank you, guys. Let me move ahead. Okay, so this is something about this a little bit part of the theoretical part of the microservices design, that each functional area of the application is now implemented by its own microservices. This is what I was saying, that you can have one service as a one functional area that is nothing but one service called as a microservice. Each service will be called by the HTTP calls called as a REST APIs, application interfaces, right? So they don't use any other protocols to call from one service to another service. They use the HTTP request, or they use the secured request, HTTP calls to call from one service to another service, right? So this is one thing very important. So all the services are talking to each other by web calls or by API calls. Most services consume APIs provided by other services, right? That is true. And services might also use asynchronous message-based communication, inter-service communication, right? So for transmitting the tokens or maybe some authentication or maybe some data transfer, that can be used by using the communication service mechanisms such as message broker or RabbitMQ, right? There are a lot of QPDs there, a lot of message-based communication systems are there that can be used. So I'll tell you one thing about, let's say that I will come back to that particular point, guys, and run multiple instances of each service behind a load balancer for throughput and availability. That is what I was trying to tell you, that I can have multiple services running inside the container. One service can be let's say you have one passenger management service, and I can deploy that service in multiple containers. and that containers can be called from the load balancer. So load balancer will be behind the load balancer, all that services will be running. So you can scale up, you can scale down. Okay, so now, so somebody might be having one question about what is API, right? API is nothing but nowadays all the applications, let me put in very simple language, very simple language. My all applications or my all services which are running in the, let's say, server or containers are nowadays working on the web. All of them are a web-based application. My trip management is web-based application. My driver management is a web-based application. My payment management is a web-based application. All these are the web-based applications. So if I want to call one service, let's say trip management want to call the payment service, so how they will call, how they will talk to each other? So they will use a protocol such as HTTP protocol with GET request, push request, delete request, update request maybe. Okay, and all these requests will be used. All these terms will be used to call the parameters from the other services. So it is simple that to talk to within the two services, you need to have some API calls, web-based API calls. That is nothing but APIs. I hope that is clear to everyone. So this is something app to DB relationship. You can say that no sharing a single database schema with other services. You have your own database. Every microservices can have their own databases, guys. So you will have passenger management database, you have driver management database, and all the stuff. So that service microservices will talk to their own individual databases. So it will be fast. It is not interdependent on some other parameters. So all the parameters will be called with the different calls as well. A service can be used as a type of database that is best suited to its needs, right? So I can call the another database service for the another application if required. Okay. Okay, now this is something called as API gateway, that is application interface gateway, right? I have just best example of the API gateway is I have hundreds of the banks. Okay, and there is one API gateway called as a bill desk, PayPal. This becomes your gateway. And if you are doing the transaction with it, you can choose any bank and you can transfer the money or you can do the transaction. So this is one form of the routing methodology, or once you can say the gateway. With the help of that, you can access multiple services in one go. In short, in the fleet management or in the passenger management, you have lots of services, and all that services can be called by using one API gateway also. And that comes on your mobile phone, and you try to book the cab. And with the booking with the cab, that all the services get interacted, or you can access all the services, whether you want to book the cab or whether you want to pay the amount, whether you want to do something, you want to manage your trip. All that services can be accessed through one API, which is accessed through mobile phone, mobile application. So API gateway is just a call for multiple services by one go. The single entry point load balancer is something called as balance the loads, distributing the same traffic to the multiple things, right? It is not really like that. Okay, the API gateway encapsulates the internal system architecture. It might have other responsibilities such as authentication, monitoring, load balancing, caching. Okay, so this can be done by using, but then this will become as a software as a load balancer, right? Not as a network as a load balancer, or application as a load balancer. So this is something about the API gateway. I hope that you got this point clear. Okay, thank you very much. Yeah, correct. So API gateway can also balance the load balancer, but load balancer can't do the job of the API. That is a thing to understand.
Sorry, just to add, the question was good. So API gateway can act as a load balancer, but only for APIs. But then API gateway does a lot more things that load balancer can't do, or other way load balancer can't will do a lot more different than APIs can't do. So they both have different purpose, but they can do each other's job as well, but very limited functionality. Over to you, Ramesh. Sorry to interrupt.
All right, thank you. Okay, guys, so this is something about the what comes in your mind when we say the service discovery, right? Service discovery is nothing but that, let's say there are hundreds, there are 10 to 15 different services or applications are running. Consider that it is nothing but let's say traffic management or cab management or driver management kind of stuff. These are the services running. Now, how it will find out, or how the gateway will find out which service it has to talk to. Okay, so it is very important that what are the services are there, that services need to be discovered. And once it is discovered by using IP address or let's say port number, that service, that particular discovered services need to be kept inside the database. Okay, and that database can be your etcd database, right? So which stores the information in such in the key value format. So service discovery is nothing but finding out the endpoints of the service, so that it can be used, that endpoints can be used to call the service. Is nothing but a service discovery. I hope that this is clear. So the API gateway needs to know the IP address and port of each microservice to communicate. Okay, so there are two things are there. One is a client server side service discovery, and another one is a server side service discovery. That is fine. You can have multiple API gateways. You can have multiple services which are talking to the client side services, right? That time you will require some endpoints. So let's say that you have service called as let's say flight management is there, and inside that there are passengers are there, payment is there. These are the subsystems are there. So one service can be called as a server side service, and another can be called as a client side service who are consuming the request coming from the server side. So both things need to be identified by the gateway. Okay, and that is nothing but service discovery. Service discovery is nothing but, in simple words, finding out how to call that service by the name, by the IP address, by the port number. But in the Kubernetes world or in the container world, it is called by the IP address and the port number. Of course, you can use a DNS also. So that is something called as a service discovery. So server type, this is something called as this is one of the example server side discovery pattern, that you have a lot of servers which are behind the load balancer. Okay, behind the, let's say, AWS Elastic Load Balancer. Okay, so that can be that is interface. The AWS Load Balancer can become your external interface, right, for the services. So now if I use this, let me explain in my diagrams how, what is this external service and what is this client side service discovery. Okay, so let me just take this one little bit up. Why we did a load balancer? Let's say this is my server, which is a web server, right now serving the request coming from the users, but not enough. That's why we can have multiple web servers here. But if you want to distribute the load, you require a load balancer here, right? So this is my load balancer. Let's say this is my AWS load balancer. All the services or requests will come from this one. Okay, and this particular servers will be VIP will be added here. But how this load balancer will identify to which server it has to talk to? So their endpoint, this server endpoint like IP address, this server's endpoint called as IP address, this IP address will be pointed to the or mapped to the one virtual IP address that is called as VIP. Okay, guys. So whenever external traffic comes, it lands to the load balancer, and then load balancer has already discovered that how it will talk to their servers. by using IP address. So that is nothing but a server side discovery. Okay. ELB can load balance traffic that is internal or virtual private cloud, and HTTP servers and load balancers such as Nginx or Nginx Plus and Nginx can also be used as a server-side discovery load balancer. This becomes a software-defined load balancers, guys. Okay, so this is something about the server-side discovery. And what is the service registry? Service registry is nothing but keeping the information of all these discovered components in one database. That is called as a service registry. And one of the best example of the service, or it is called as a database also. And the best example of the service registry is, you can say, Netflix Eureka or your etcd, right? So this particular, whatever the service is discovered by the various components will be stored inside the some database, and which will be used again and again to call the services. So that is called as a service registry. So it is a just it just holds the data information about the service discovery components. Okay, so before going to the now deployment strategy, which is a very important discussion, do you have any questions? All right, I think everything is taken care of. How we can choose the load balancer capacity, since in big environment you need solid load balancer. Oh, I know that when one load balancer can serve the request of request at least 4 million transactions per second. That kind of load balancer, that too I have seen long back. Nowadays load balancers are really fantastic. So you need to check with the vendor that what is its throughput, right? So that is the question. Good question asked by the how I can pronounce is your name, Samar. Okay. All right, Vinay is asking, so load balancer decides between the API gateway and the actual APIs, API gateway and actual APIs. API gateways can be behind that also, behind the load balancer. API gateways are called in the application, right? And API gateway can be multiple servers also. They are also required to be load balanced, like a build desk is a API gateway. And if a lot of things are happening on the build desk kind of or PayPal, you cannot have, we just can't keep one server. That service can be also behind the load balancer. So it is just software which we are calling, which we are just calling the link behind it. Okay. Load balancer scales automatically. Okay.
Sorry, I can answer. No, load balancer, they don't automatically scale. You need to tell them as a scale requirement. So Ranjit, depending on which cloud vendor you're going, you have to define some you need to upgrade or pay higher one, move it to a higher level.
Yes,
Okay, I
yeah,
think I've
correct.
covered.
Yeah, I think almost all questions are covered, right? If
Yeah,
anything
let's
is
continue. Otherwise, we'll make sure we'll take it after the class as well. Yeah.
okay.
Yeah, so load balancers must be replicas. Will define ideally to avoid single point of failure. Anuj, these are all configured, taken care by the like by the company. Yes, so cloud vendor usually take care of that. Okay, great. Thanks, Vinay. Surinder is saying in design flow, should we need to include both API gateway and Azure load balancer? It's your choice, Surinder. If again, we'll come to that point when we look at the design part. But Surinder, if your API, if you have an API gateway requirement, which is like when you're exposing APIs outside the for internet, then yes, definitely you need to have you want to have API gateway. But if it's all internally, it's all down to the requirement, Surendra, I would say. Yeah, but it's always good practice to have API gateway with a load balancer as well. And it doesn't need to be Azure load balancer. It could be any load balancer. It could be AWS. It could be F5. It could be anything. From which server traffic will be routed through server, how to identify. Okay, Santosh, we'll cover these things when we come to the deployment and architecture. We'll be covering that. So traffic will be your application will from which server traffic will route through servers, how to identify. Okay, someone who's defining these or designing, when you're designing the application, that time you'll design which application needs to talk to which application, and then how traffic is done. The network engineer or we will be setting it up. Hold on this question when we go for a more complex application towards, and there are more complex applications, we'll be defining services, and that time in the labs you will be able to understand those, Santosh. So hold them for more advanced. Anu saying, you said we will cover in troubleshooting module. Should this not be decided the design state? I'm not sure what was the Anuj. Hold on, let me pick your question again. Load balancer must be replaced. Anuj, can you unmute yourself? In what context you're talking about?
Hi, Atul. My question was, what are the recommendations to solve the distributed transaction problems in microservice architecture?
What I'm trying to say is we are not going to cover it right now. Later in the module, we have a distributed transactional settings or like a distributed transactional deployment. We're going to cover that. I don't want to tell you what I'm trying to say is this topic is going to cover. We'll discuss that at the time. Today we are very early. It could confuse guys. Are you coming first time or have you attended the sessions in past?
Just one session from Mamta.
Yeah, so you've attended the one batch, right? So hold these questions. We'll cover that when we come to the future. There's a module coming at the time of advanced distribute, uh, uh, basically persistent transactions. We'll cover those. I don't want to confuse people or tell something which is more advanced. So that's what I'm saying. So hold that question. We'll be covering that, coming that towards at that
Right.
point.
I understand. I think my question was more around the architecture of microservices, not really to the to the configuration level. But that's fine. We can take it
Yeah,
later.
hold that question. We'll come to that point when we come out about persistent. Yeah, or we'll take it offline. Piyush will cover that. Okay. API gateways and software deployed on some container as a microservice. Asus, it doesn't need to be in a container. It needs a processing. API gateway is you're right, it's a software, but it doesn't need to be container. It can be run on container. It can run on a normal machines as well. So past, we used to run it without a container. We used to run on a virtual machine itself, but it's down to deployment. How do you deploy that? Yeah. Over to you. Sorry.
Okay, not an issue. I think that's fine. The good questions are really good, and we'll take it whenever the topic comes. We'll definitely take that one. Okay, so deployment strategies. Okay, so earlier this was there, right? We have to consider about the physical or virtual machines, that if you want to deploy any services, you can deploy in the service A in the instance 1, service B in the instance 2, something like that, right? So it was earlier was a host or physical machine. So this was a deployment strategy, multiple services instance per host pattern. Benefits was resource usage were really efficient, because one host machine or one physical machine used to have the run the multiple applications on it, right? Drawback was if something goes down, there was an issue, right? Little or no isolation of the service instances. Okay, so that was the issue of if you are thinking about deployment strategy called as deploying the application on the single virtual machine or physical boxes. Okay, so what is another strategy that is you can deploy? You can straightforward use a virtual image, and you can deploy that virtual image on the as a service in the different virtual machines. So any service which is packaged as a virtual image, and that can be started as a virtual service, as a service in the virtual box or virtual machine altogether. So this is a better advantage. You can have multiple applications running on one host, but they are in the isolation. So service instance per VM pattern, you can have one service in one VM. That makes life easier. Package is service as a virtual machine image, right? So we can create an image out of that application or this one virtual machine, and you can reuse also, right? Let's say that if you take a backup or snapshot of the virtual machine, you can reuse many times whenever you want it. So earlier the drawback was the physical machine has been really nicely covered by the virtual boxes. Okay, what are the benefits of it? Each service instance running in complete isolation. So you don't understand this. This service doesn't know what is running on the next VM, which is on the same host. There is a huge isolation. That was not the case in the physical boxes. And the virtualization, they are really isolated. Okay, integrate with the features like load balance, LB and AS, right? So, and what are the drawbacks? Drawbacks are like difficult to react quickly to change in demand, because it is same like your physical box, only packaged into the your virtual machine. So it is same way we have to react to the virtual machine. Only thing is that the management of the backups and restoration of the virtual machine was quite easy and quick. slow to build and deploy due to its size. Okay, and these were drawbacks. And another strategy which we are going to see now, and that is what this course is all about, that how you can deploy your containers or the service inside the containers. So let's say that you have a service defined in some code. Okay, you can use some image building methodology such as Docker file or other methodology to create a container image. And once you create a container image, you can deploy that image in any virtual machine or any physical machine also. You don't have to just have a virtual machine to deploy the VM container, sorry. You can deploy on the bare metal machine as well with the operating system, right? And that will run in as a container. So on one host, on one entire host, I can have multiple containers running with multiple different services, right? So I can have one service running here. I can have another service. As per my knowledge, I can deploy at least 255 containers on one node or one host, right? So you can think about that. You can deploy at least minimum 255 services on one node as well, right? So this is what strategy. What is the strategy? In this containerization, you have to have one service code. That code can be packaged as a container image, and that container image can be deployed on the different virtual machines or a physical machine inside as a service, right, inside the container. So what are the advantages of it? Service instance per container pattern. These are very lightweight. Package service as a container image. A container image is a really file system image consisting of the application and libraries required to run the services. We will be discussing about what is the container, and that time I will explain you how the container actually formed on what it contains. We'll see the actual pictorial difference between the what is virtual machine, how it was we used to deploy the application on that, and when we are deploying the application on the container, actually how we deploy it and what is the difference between them. We are going to see in the detail in coming slide. Okay, and what are the benefits? Each service instance runs in a complete isolation in the container. So it is a job of same job of the virtual machine can be done by the container itself. You cannot have more than 128 virtual machines on one host, but you can have 255 containers running on one host. That is the beauty of it. And it's absolutely lightweight. Your virtual machine can go in 1 GBs, but container can be in MBs also, right? So this is a deployment strategy for the containerization. And there is one more pattern, deployment pattern is that nowadays people use, that is called as a serverless pattern. You might be heard about that serverless computing. So best example of the serverless computing is Lambda functions, right, which we use. So it is a small code which can, all the infrastructure and everything will be taken care. You just want to deploy the code. So once you deploy the code using some function called as Lambda function, automatically behind the scene, your cloud service provider will create a server for you, all the platforms for you, infrastructure for you, and it will just deploy the code on the top of that particular server, and you will not come to know that, right? That is nothing but serverless pattern. So serverless microservices are deployed within a serverless vendor's infrastructure, right? And only run when they are needed by the application. So whenever you are calling that Lambda function or whenever they're calling that API, that time only the computing power will be provided and that microservices will be started. So it's nothing but kind of serverless architecture. But of course, you need to have some computing power to run it, right? So, but that is completely behind the scene. You don't know from where it is running and for what exactly it is doing in the behind, right? So that is something which is serverless is all about. Okay, so you can divide the functions as per your applications, and you can write that functions in one code, and that code can be put it on the as a serverless application through some functions called as Lambda functions or Azure functions or Google functions. This is another strategy people nowadays using if you have the small code by using the Lambda functions. All right, so these are the different strategies which you have seen, guys. Let us see now Docker. Okay, and we are
Should we
very
take a
much
break before we go to Docker, because how much time has happened? Like we almost now. Sorry, other.
okay.
What do you think, guys? We are almost now, how many hours? 2 hours are close. Yeah, let's take a logical break at that point. Yeah, yeah, please. Let me take questions. So host means here, Vipasa, host here means a machine or a node. Host, when we say word, host means a virtual machine, or it's just a fully fledged operating system. What are the benchmark for number of services in a host versus number of containers? 255. Okay, Anant, I think I may not be. Can you go back to the previous deck? Yeah, can you go back and open and let me take questions? And guys, this is the opportunity now. We unmute yourself and ask questions.
Yeah, Atul, I will have one question. Okay.
Sure, please. Yeah,
Okay.
Vinay, go ahead, please.
So my question is actually in the previous diagram, Ramesh was sharing, Ramesh, right? If I'm not wrong.
Yeah, Ramesh.
Okay. Ramesh was sharing that one container, one virtual machine, right? So in one node, we can have multiple virtual machines, right? Is
No,
it
Yes.
mandatory?
Okay, so node is a physical machine.
Yeah.
Node could be, okay, different people use word node interchangeably. It could be a physical, it could be virtual, but yes, okay, fine. You're talking about when you say node is a bare metal machine, on that you're running virtual machines, okay?
Yeah, virtual machine. So is it mandatory to have one container deployed in one virtual machine, or we can deploy multiple? When I say container, means kind of one multiple services running on one virtual machine, right? Within and each in one container, correct?
Yeah, no, okay, so first of all,
Mm-hmm.
you have a bare metal or a machine. On that you can either install an operating system directly,
Yeah.
or you can install a virtual machine. Okay, multiple virtual machines. Within virtual machines, it's not recommended to have one container per virtual machine, because that defeats the whole purpose. Otherwise, I would then rather install, if I do one container per virtual machine, then that will not be very beneficial for me. I'm not using my resources very well. So typically I run multiple containers within virtual machine.
But in the diagram, actually, that's how Ramesh was showing, right? If you can go to that diagram, if you don't
Can we
mind.
go back? And I'm assuming this is just to give an example that you can run. Okay,
Yeah, so that's why I want to clarify. Actually, I want to understand. Yeah.
Oh, this is
this
just
one.
an example here. This is just an example. He's saying service per container pattern. So these are, again, when we come to the design pattern, so there is a concept of pod and containers. He's just saying that. One second, Ramesh, do you want to cover this? Because
yeah, I will cover that. So Vinay, right? Vinay was talking, right?
Yes, sir.
Vinay, see, on one physical machine, we can have multiple virtual machines, and inside one virtual machine, you can have multiple containers.
Yeah.
Right,
Okay.
and that multiple container can have run multiple services, various services.
Okay, but that is the kind of availability, how we can do that. But what is the ideal way actually to do that? One container, one service, or one container, multiple service actually?
No, if your service is requiring a more number of computing power or something like that, right? You can have you can have multiple containers. Let's say that.
Oh no, sorry,
Ideally,
Ramesh. I think let me take. I think your question was related to so the application deployed on top of the container. That's what you meant by that. I think, Vinay, is that correct?
Yeah. Yes.
So application, ideally you would put one application per container. Okay. But certain scenario you might have that, oh no, two applications must always coexist. You can run multiple applications on a container as well. Okay. Now, when we say service instance, now that's why I don't want to confuse you. Service has a different meaning. An application, the two word I might put say is a application. So for example, you're running a web service or web server. So or my Nginx web server or my Apache web server, or Nginx load balancer, or maybe a database instance. So that I'm going to typically I would run one per container. And then that container can run on multiple containers on one virtual machine. And multiple virtual machine on one physical device.
Yes.
Okay. Now
makes sense.
it might get a little bit complicated when we come to the context of when we come to Kubernetes and when we come to pods, because pods will have something else. We'll cover that pod as well. So hold that question when we come to the
A little bit confusion. I always get confused between this container and the image that we will deploy. So container is nothing but we are referring one image, right, of that application.
No. Hold on.
Yeah,
We'll come.
I'm getting
I
confused.
don't want to jump onto that. We'll come.
Okay.
We are going to explain very well when we talk about image and containers. Using
Okay.
image, you can create containers, and using one image, you can start 100 containers, 200,000 containers. So image is nothing but a
Okay.
template through which you will start container.
Okay.
Sorry to
Right.
interrupt.
But
Okay,
Atul, just one
Atul,
question here. When you say container image, like this service is packaged as a container image. So here service means one service, like A, B, or C, or it is, I mean, it is individual service that is packaged as a container image, or multiple services are packaged as a container image. Like if you compare this diagram with the previous diagram, we
can
have
you go back to the
shown
previous?
on one.
Okay, I'll explain you. Let's do one thing. Can you go back to the previous slide where we have multiple like web services?
Yeah,
Can we
there
go
it
back?
was mentioned A, B, and C, right?
Yeah, let's go there.
Like, yeah, this one. So here on one physical machine, we have three different services
Okay,
with
now hold
instance
on,
of
because
each.
that's something. Service concept is little bit different because service has a different. There is a application, there is a service, and when we go later, we'll come to go further down. Go further down when Ramesh, can you go a little bit further down?
Yeah.
No, back where I said web we're comparing VM versus go up.
Okay.
You know, at top where I said microservices for the top, go top. We compare monolithic versus microservices. Yep, this. Can you make it make bigger? Okay. So now here, if you see passenger management is a application, or we call application or a service running. Think of it as an application running on top of a container, and you can have 1, 2, 3, 5, 10, as many containers as you want spin off of passenger management, and all those passenger management applications will be spinned off from one one image. So one image can spin off 100 right now we are representing here one passenger management. Like that, you can have spin off 100 passenger management. In front you will have a REST API which will, or you might have a load balancer or some service. In front of that there will be service. That service will be forwarding request to all these multiple instances of passenger management. Similar to that, I will have another container called driver management, and I can have 1, 2, 5, 10, 15, 20 containers of driver management, which will be spinned off from one image of driver management image. Does it make sense?
Yes, Atul. So, like if I understood it properly, one physical machine will have multiple virtual machines, and on each virtual machine, we can have multiple containers, and
Yep.
each container can have different services running
Or
that
different applications
service
deployed on
container
top of it.
image.
Yeah.
Yeah.
And I think
So,
hold that question. Yeah, okay, yeah, you're correct. But we are coming up in subsequent lessons. We are going to teach all these, or Ramesh is going to draw the diagram and explain all of these things. But
just one question, Atul. Just one question. Like on each container, we will have one passenger management service, one driver management service. Like we can have all also on one container, or is it one passenger management on one container, one driver management on different container?
yeah,
Can
so
I take the
technically you
question?
can deploy one
Okay.
on within one container, both passenger and driver. But then now you're bringing two applications together, and if you need to
Yes.
do something, if you need to spin off, you need to then you're overloaded the container. If there is a specific requirement, your technical dependency that these two applications must always run in the same container, then you will put it. But ideally,
Okay.
in a best practices, I want to keep all my services separately. So my passenger
Separate.
management will
Okay.
be in one container, my driver management will be in another container. I don't
Okay,
So
want to
got it.
because I think as explained by Atul, because containers are created from the image, right?
Yes,
So
that's right.
and normally one image will have one application as the best practice.
Yes.
Okay, thank you. Thank you. I think it's a nice clarification for everyone. Thanks a lot,
No, it's going to
Atul,
come. Like,
Kishore,
so we are
everybody.
still at a very early stage. We have a definition where we talk about images, what are the images, how they're built, image layers as well, and then how images are spinning off from containers. But it's coming. So it's
I think
like,
a few words
hey,
actually
Atul,
we use them interchangeably. Actually, that's cause confusion.
sure,
That's
sure,
what I
sure.
understand.
Sure, no problem.
Atul, just a question
Oh,
here.
one at a time, one person. Put in the chat window
Yeah,
and I can
this
click that. Yeah.
is yeah. So this is Kamlesh here. I just want to have a single, like we have a bare metal box
Yep.
with a huge capacity, let's say,
Yep.
with huge number of CPU and RAM, and I have an OS running on it. So instead of me putting an hypervisor there and creating a VM and then deploying containers in that particular VMs, which would be the better option if I do that way, or if I just churn the multiple containers on that bare OS?
No, so okay. So first of all, bare metal, the containers need an operating system. So you either put it under virtual machines and then do it, or you install a machine and on that install an operating system and you can do it there as well. Now it's down. I think it's down to you on that architecture. Virtualization will add some extra layer if you can afford. If you don't want to, you can. I wouldn't put a virtualization if I can't, if I don't need to, because why
Yeah.
to extra put. But let's suppose you might say that I have a big machine and I don't want entire machine to be production, or I don't want to give a dedicated machine to production test environment. But I also want to keep test environment different from UAT environment. So no one can I want to keep separate. So it's all down to the architecture, I think. But if I get a
Okay.
chance, I would put everything into without any operating. I will minimize the basically restrictions. But then if I don't want to give one full server to an entire team, then I would say, or put it under things. Yeah.
VMs. Okay. Okay. Great.
Now,
Yeah,
David is a very good point. He's saying not to overload the containers. Containers are bound to you're perfectly right. We don't want containers to be overburdened with, because if it container dies, which are they are born to die, as we always mentioned in past as well, then it will take down your multiple services together. Moreover, if you want to scale up, your scale up will be a problem. Or if you're testing it, if you club together multiple applications, then you need to touch base or test all the things. Yeah. Yes, there were other questions as well. As long as we have a question related to this, unmute yourself and ask, please, related to container, image, virtual machine. And then I'll pick up other questions. We'll take a break and then we'll come back and questions.
Hi, Atul, I have a question. Suppose I deployed passenger management in one container.
Yep.
If the container goes down, what happens? Like how that will
Okay, we are going to cover all these things on container coming back, recovery, all those things we are going to cover. But you don't run just one container of passenger management. You run multiple copies of passenger management. If it goes down and you don't have any Kubernetes, you have to manually go and start another container. Okay, or that's for the reason you spin off maybe 5-6 copies of passenger management container. Again, we are going to cover all these things. Yeah.
So the Kubernetes will do that.
Yeah, Kubernetes will automatically do that. If Kubernetes will, you say that, hey, I want 5 passenger management containers, it'll do 5. If anything goes wrong with the container dies, Kubernetes will continuously monitoring, it'll automatically start off another container for that.
Okay, thank you.
Okay, we are going to cover all these things inside the program. Next one, please, as long as we have it within this diagram. Is everyone clear? Image. Again, we are going to go deep into image and containers from that image. No?
So Atul, I have a question here. So the thing is that the REST APIs are used for communication between
Sumanta, not audible properly and you're going away. Your voice is coming from far.
So, okay. Can you hear me now?
Yes, now better. Yeah.
Okay. So what I'm saying is the REST APIs are being used for communication between the services, and the services are and the communication is going to happen through REST APIs using the port numbers and the IP addresses, right?
Mm-hmm.
Correct, correct.
Yep.
Okay. So, but then, are there any other internal mechanism like,
Yeah,
you
so
know,
hold that question again. There is another thing called in Kubernetes, when we come to the Kubernetes, there'll be another thing called service itself. There is a concept of service. What is that? I don't want to jump onto that right now because it might open up more questions. There's a logical point we're going to come. For now, assume there is an IP address and port number through which we are going to access these endpoints. Yeah.
Okay, thank you.
Okay, so hold that question till we come to what is a service. So in Kubernetes, there is a concept called service, and service are a different type, kind of a load balancer, node IP, node pool, other things. I don't want to confuse, and that's why I don't want to answer too much as well. I only want to tell you what you need to know, because it might further confuse and you will get confused as well. So hold that question, but for now, assume that it's going to connect through a port number and IP address. That IP address could be a load balancer, it could be different things.
Sure. Thank you.
Apple, I had earlier inquired about the numbers, the maximum number of containers per host.
Let me answer that. Good question. Sorry, I missed that. So what happens is very good question. How many containers I can run on a machine? Machine could be a virtual machine. It could be direct operating system machine. So first of all, you need to identify how much memory and CPU your container will take. And you can define, and we are going to do the lab where we're going to do a restrict and say, I want 2 MB of memory, I want 10 MB of memory, I want 1 gig of memory, I want 2 gig of memory. So it's down to your application. For example, in this particular case, how much memory a passenger management you want to give, or your application developer have decided or designer have deployed. And so you can say, my application runs on a 100 MB. And you have a 2 gig of machine, so 100 MB. Operating system itself will take maybe out of 2 gig 1 gig, so you are left with 1 gig of memory. Now each machine is taking, for example, 100 MBs, so you can run 10 approximately 10 containers on that. Similarly, if your CPU is being used by the container of 1 CPU, and you have a 12 CPU machine, you want to give maybe 1 or 2 CPUs for the operating system, and remaining 10 CPUs are left. Or maybe you just have 2 CPU machine, you want to say maybe 1/10 of the CPU per container. So it's down to what your application is being using, and you're limiting those containers by the CPU and memory size. And you can do all those things. How to do? Stay tuned. We are going to cover that in a lab. Make sense?
Absolutely. Thank you very much.
Oh, great. Any other question related to this, as long as lab? Yeah.
I have a
Sorry,
question.
Ramesh,
Like,
we're going to take a
how
break, but
the
let me answer those. So I hope you won't mind me picking up these questions. I know you're an expert, and correct me if I'm wrong, or if I'm going wrong, and stop me at the time, and then you pick those questions.
Yeah, sure. No problem.
Yeah, over to you. Like,
yeah,
who's asking question? Yeah, we're going to take
how
a
the
break, just a
API,
few minutes, and we'll take a break.
how the API gateway, like who will provide that? Do we need to set up anything while the?
Yeah, so Sudhakar, we are not covering in this training program API gateway, but yes, if you can put it, you can do it without API gateway as well. You can put just a load balancer. In this case, we are putting API gateway, because API gateways, if you have a lot of APIs, you can put an API gateway. So there are API gateway administrator. You can be API gateway. You can buy like these API gateways are available nowadays. You can deploy. There are softwares available like API. There are a lot of API gateways available on the cloud as well. So the role of API gateway is kind of a gatekeeper. It can do load balancing. It can do like a service IP transitioning. It kind of act as a gatekeeper, which will do a lot of other things for you. Maybe intrusion detection system. It may be hiding endpoint of backend services. All those things. So who does it? There'll be API gateway administrator in that company.
Oh, that means it is optional. If you want, we can use or not.
Absolutely. It's a totally optional component. Yeah. Absolutely.
Okay, thank you.
Hey,
Next
Atul,
one,
yeah,
please.
this is Naveen. So, if we go for this example, which is on our screen right now, so
Yeah.
I can say passenger management, driver management. These both are the two applications which is can be run on the different containers.
Microservices. Yeah.
Microservices. Okay, and suppose they have the one database. So, if you create the multiple container, one is for the passenger management, another one is the driver management. So, is it necessary to create a copy of the database itself to run in the different container, or two different container can talk to the one single database, like they can
Or two
update the
different containers
database?
can talk to database. Again, hold that question. We have a persistent store application. These passenger management and driver management can run and connect to the same database as well. So passenger management and driver management will talk to something, another thing called service, and that service will be exposed to my database container. So database container will be exposing their database host number and port number through a service, and that service will be talking. So you can have two services or one service, passenger management talking to passenger and driver management talking to driver, or both talking to the same database. Again, hold that question again. We'll be having a lab about application talking to the database in a
Okay.
persistent.
Hello.
Sorry, 1 second, just one. Was that any other question from the previous? I forgot who that question was from.
No, it's okay.
Yeah.
So you
It's
just
okay.
say like hold the question, I will ask.
Yeah, so if you have to jump onto, we have a lab on database part, how to do later in Kubernetes class. That
Yeah, I
Sure.
have a
Just
question.
just answer to this question. One second. Just answer to
Sure,
that
Ramesh.
question. Your multiple services can talk to one database. You can call them through the service. Okay, is that clear?
Uh,
Or you can create a multiple replicas also, but that will not be hold them in the good position. So it is not advisable.
Yep.
okay.
Next question,
In
please,
the
Anthony.
Yeah.
in the area of load balancing, what
Mhm.
exactly does load balancing does? What does it really do? What's the
Sure.
function
Sure.
of
Anthony,
load balancing?
let me explain that. So let's suppose you have two backend services. You have two servers, exact replica of that. Okay. And so first of all, you will, in this case, let's suppose you have one passenger management. What happens if this passenger management goes down? You're gone. Like no one will be able to do the passenger management. Will not be fulfilled. So what you do, you
Mhm.
create two copies of passenger management and front end by a load balancer here. So what you see, REST API assume there's a load balancer, and that is two passenger management copies. So request will come to the load balancer. Load balancer will forward it to either first copy or second copy. Okay, any of these application. What it helps, if my application goes down, my other copy will take care of that. Or if I want to have more load, I can spin off one more passenger management. My load balancer will distribute the traffic. So load balancer does two things. One is it balances the load, it does high availability, it does it take care of failover, and it does scalability, which means I can add more and more load onto the system. So it balances the load on the system.
Ah, okay. Thank you.
Okay, next one, please.
Atul, I have a general question, not on this. So, what part of OpenShift is going to cover in these sessions?
We are not
In
going to
this
cover
program?
OpenShift in this session. If you have any specific question, we can answer that. But OpenShift, we are not covering OpenShift. We are doing Kubernetes and Docker. OpenShift is a Red Hat Enterprise Kubernetes implementation of on Red Hat on IBM Cloud. But we are not covering that OpenShift in the training.
Okay. Yeah. Thank you.
So,
Yeah, Vipasha, you can take a break. You can come back. We're going to put a timer. We'll be taking 10 minutes. I'm just answering the question. Vipasha, you can take a break.
Atul, I have a question. So
Yep.
this, as we have seen now that we can have multiple, containers in one VM. Okay. So what does that mean? That it is highly scalable, right? So whether any manual effort is required, okay,
Come
if you
again.
have
When
to
we have
create,
multiple containers in a VM,
yeah. So we have seen here that we can have multiple containers in a VM, right?
yep.
So how it is going to take place? Like in the sense, if there is a requirement that instead of one container, if I have to host 5 different containers, okay,
Yeah.
in a virtual machine, is that going to happen automatically or any manual intervention is needed? You have to
Okay,
create it manually.
so if you're doing just Docker, then you have to do it manually. So you need to spin off 5 containers, and we're going to cover in the class. We'll show first manually. Later, when we come to Kubernetes, we just tell Kubernetes and say, hey, start 5 copies, and you have 2 machines, or you can say spin off 10 containers, okay, or 10 applications, 10 instances of application, and Kubernetes will see that hey, there are 2 machines, so it'll distribute load equally 5 5. Or Kubernetes is intelligent enough, you can also say always start 5 machines or 8 machines on one node and 2 machines on. You can define what all configurations you want, and Kubernetes will do it for you.
So basically, if I need 5, okay, and the resources are not enough in the virtual machine to spin off another 5 containers, then Kubernetes is intelligent enough to make the decision that 5 is you don't have enough resources, so better you go with 4.
No, so I don't think, Ramesh, can you do it? It doesn't tell you that, oh, you can't, it'll be erroring out. And if you can't do, it'll like,
It will
if you don't have an
No,
underlying
at that
infrastructure
time,
to do,
pod creation will fail. Okay,
yeah,
if you have one,
Oh,
pod
okay.
creation will pods will not start up. Okay,
yeah,
so
let me
that
you
answer
should
this
particular
have.
question.
container will not start. Okay.
Let,
But it will not
let me
handle the node. It will not do the operating system for you. Kubernetes can only manage the container, and we in Kubernetes there's the concept of pod. Will come to that point, and pod is nothing but collection of one or more container. So it will not be able to spin off, and it'll only do four, and in your Kubernetes log you will see that it is unable to start fifth one because it doesn't have enough CPU and memory, for example. Yeah, so you need to
Okay.
give
see.
them the enough CPU memory.
Okay, Atul, just to add on what you are saying right
Thanks,
now,
Ramesh.
in case it is a Kubernetes has one high availability structure. So it has a multiple nodes actually. So in case one node doesn't have enough memory or resources, CPU and memory, it will check if there is another node which is having enough memory and resources. So it will distribute the pods accordingly. So if you want to launch 5 pods, it may launch 3 pods on the one server where resources are available. And if there are no enough resources, it will put it on the another node as well.
So I think we are considering containers as pods, right? That is other word.
Yeah, so container is no, pod is a collection of one or more container. It's typically you can deploy again. Think of as a pod as a container for the time being right now, but actual definition of pod, what is difference in pod and container when we come to Kubernetes container, Kubernetes will come to that point, we'll discuss. But for now, assume pod and container interchangeably.
Okay, thank you.
And Ramesh Vishwesh, I have a question. Can you cover difference between the microservice or API, WSDL?
Oh, so hold on. Wishes I was about to cover. So SOAP, WSDL, SOAP services will not be able to cover here. We have a separate program called we have integration cloud or SOA. In that we cover. I'll give you a separate, maybe if you want, we can bring some overview and basic concepts from API from our that training program. Wish. So if you drop email to support@k1academy.com, give team probably a week or so. We used to run a SOA program. I think we still do service oriented architecture and Oracle integration cloud. Integration cloud is still there. Integration cloud is for integrating my business applications with other systems. In that we have REST, SOAP, WSDL, all those things are covered, including API gateway as well. So, but in that we cover Oracle API gateway. Okay, so we will bring some information because I see there's a lot of demand about API gateway. SOAP, WSDL, and other courses have also added. We'll put it in under bonus module. Yep, Wish. We'll
So
not be covering here
are
because
you
it will
going to
become.
cover APG in that, Atul, in the API gateway?
No. We are not covering API API. We used to have that. We have removed that because we are only focusing on Oracle integration cloud there.
Okay, no problem. So my question will be, whenever you have time, you can clarify.
Sure.
One is Kubernetes admin and one is Kubernetes developer.
Yeah.
I want to understand the difference in their roles and responsibilities.
Good. I'll put that. Okay, we'll cover that.
Okay.
Yeah.
Thank you.
Good, Kalyan.
This is Sainath.
Yes, Sainath, tell me.
Hey, I have a question. So if I hear you guys correctly, I think you said we can spin up a maximum of 255 containers, right? So is that a limitation for the whole of VM, or is it for each service if I have multiple services running on the same VM?
Let me answer this question, Atul. Yeah, sure. No? Okay, so 255 is the maximum number. See, basically it is a operating system layer constraints are there, or the containerization constraints are there. You can have 255 containers running on one machine. If you have that is also a huge number in case you are having a real production applications. Okay, right? Is that okay?
Yeah. So I mean, in that case, you usually scale it into different servers. I agree, but I mean, you don't run 255 containers of the same service on a single server. I would understand that, but my question is more of like, so the maximum limit is 255 for the whole of VM, or you would have, if just in a case you would have multiple 255 containers of each service. Like for example, if I got two services,
maximum limit is 255.
Okay, it could be shared across any number of services I have on that VM, right?
Yes, correct. One service can have multiple containers, maximum 255.
Okay, so thank you.
Hi, Ramesh. Sorry, can I go first, Ramesh? So my question is, right, I am from a middleware background. I'm a middleware engineer right now. So my organization is exploring into the microservices architecture, and they are asking us to set up the Docker and Kubernetes and also the API gateway. So in the outside world, what kind of role we expect running these codes? Should we be covering also the API gateway management and publishing everything, or?
No, API gateway won't be managed here, but we'll be discussing about the controllers.
No, but control is totally different. So I understand your wish because I come from that middleware background. So we are not covering API gateway. Probably which API gateway your company is using? Because API gateway itself is huge
Yeah,
topic.
they're exploring service mesh and APG. So I was wondering, would we be doing that in the outside organization also, like or somebody else doing that by learning this program?
No, so we are service mesh. We are planning to add into, as I said, CKAD. We are already covering in CKAD, Certified Kubernetes Application Developer, and maybe that is a point we might bring a little bit more about SOAP, REST, web services, because all these web services are concept from a developer or development point of view, or that point of view. I want to hold. I don't want to make this as a, because I want to focus on Docker Kubernetes. I don't want to make it right now web services or API gateway training program, please. Yeah, so we'll come to that point when we move on to that. API gateway. Again, guys, don't limit your questions like these on here. We can take these questions or more questions in WhatsApp group. So don't limit and think that, oh, you can only ask these questions here. Please use a lot of opportunity in WhatsApp group. A lot of you guys already asked these questions, but wish if you ask these questions, some of these questions in WhatsApp group, I'll try to find more information for you on those. Yep.
Yeah. Thanks for that.
Okay, there was one more. Santosh, go ahead, please.
Yeah, Atul, Atul, I just want to ask you that, like how, Amazon will handle the microservices in, in e-commerce.
Okay, so think of it as each, like, can you make me presenter for 1 minute? And then I'll hand it over, and then we'll take a 10-minute break because we have taken a little bit longer. And it's totally fine. Don't worry. Make me presenter. Okay, so think of it as a like okay, how do I move this a little bit more on that side? Sorry. So if you see now on console.aws here, okay. So do you see on top right hand side /console? Okay. So think of it as a /console is a one application. Console is one application running, or FSX on top of here you see FSX. It's one service running. Okay. Or go back to on services and go back to maybe billing, and if you see billing, another service. So that's one example of all these services different. Okay, that's one. Now I go to actual shopping cart amazon.com. Okay, so now if you see, this part might be coming from a different service. This part you see here, hi Atul, this portion is maybe coming from a different thing. My orders, all my orders is a different service. Or similarly, if I go to my feedback, or let's go and do a product and say all product best sellers. Okay, and now within that I go onto this page, gift voucher, and if you see product features, this feature might be coming from a different service. The customer reviews, this might be a different service. All these customer images might be different service. So at any point in time, if this service is not available, the applications have written in such a way saying that hide this, and maybe reviews is another service. So this is all different services combined together and mashed into one particular page, web page. So you can do services like that, or it could be as I said, complete application level as well on here. So there are different ways you can code these applications or run and build it. Yeah. Does it answer your question, Santosh?
Yeah, thanks.
Okay, great.
So Atul, the services that we create and deploy on like kind of on cloud, like they are different, and the services given by the cloud provider like Amazon or Azure or like Google, they are different, like billing service, right? Container service, or maybe data source service, right? So that's what I say, like this interchangeable uses of like terms, actually they confuse a lot when we talk, when we discuss.
If you look in layman's terms, service is nothing but someone is giving me something.
Yeah,
I
understand, because I am a developer. I understand the services. I'm just saying when we discuss in the course, actually when we talk, that's how we get confused actually.
Understood.
Because like in the diagram we say service. Okay, what the service is now, and then we are talking about the container there, virtual machine there. Then how we say how the service and containers and virtual machines are there. So those services nothing but the service provided by the cloud provider actually.
Yes, that's right. That is right. That's right.
Thank you.
Thanks. Okay, so we'll take a break now, guys. We have gone a little bit more. Should we go to 10-minute break or 15 minutes? Guys, wait 10 minutes or 15 minutes. And as I said, initially we go a little bit slow and take questions. So don't worry about it. We'll make sure that if we need to extend the session, we will extend the session. Vinay is 1:15. Anyone for 10? I'll probably grow 2 more answers. 15. Oh gosh, I'll do 3 more. Okay, 10, 2, 1, 15. Okay, let's go with 15 then, guys. We'll take a 15 minutes break. 15. Okay, great. So I'll put the timer, or Piyush, can you put a timer, or Ramesh, can you, someone of you share the screen, or let me put a timer here on my screen. Duck timer. Okay, guys, I'll go on mute now. Ramesh back? No.
Yes, I
Okay,
am
so
back.
guys, let's
Let's
stop it
start.
first of all. Is Ramesh back?
Yes, I am back,
Oh,
Atul.
great.
I hope that you can hear me.
Yeah, yeah, I can. I think you can take control. Look, I won. Great chance. Who had put in $20 on that? I'm going to send you the bill now. Okay, great. Okay, let's over to you. Sorry, let me make you presenter, and I think we should start recording as well. Piyush, or can you start recording as well? Or recording is on. Great, thanks.
All right, guys. I hope that everybody is back after the nice coffee or maybe dinner or maybe something like that. Let's start with the main topic of the day is Docker. So let's discuss about what is a container basically. Docker is one of the container engine, so we will be using it. So this will be our agenda for this one. Let's see how much we can cover today. We'll be discussing about the Docker basics concepts, architecture, image, networking. This is what we are going to discuss. So mostly I will be discussing about the basic concept and architecture right away today. So as well as we'll try to install the Docker today, and we'll try to pull some images as well. Let's see
Yeah,
how
one
it
more
goes.
question before we go further. Sorry, guys. Now based in previous batches, people were asking that 4 hours is too much. So are you guys okay with 4 hours or 3 hours will be better? And again, we are not cut shorting the classes. We might extend them a little bit better. But what do you think? 4 hours or 3 hours? If I want to vote, okay with good for 4 hours. Okay, no, I just want vote. No, no, vote there. Three is good. I'm getting a mixed one. Okay. Oh, there are a lot of threes. Okay, I don't want to commit right now anything. And there are mixed four. We are not going to limit. We are not going to delete anything, or we are not going to remove anything. But we might have a little bit more number of sessions as well. Instead of is like whatever 1 hour left. But let me discuss with Ramesh as well. What is the best one? Seven. Okay, four threes. Okay, no. Okay, but again, as I said, we are not going to. We don't want to rush. We are not going to rush. We'll make sure that we get the same value. It's a little bit more extended period as well. I see a lot of three. There are a
Atul,
couple of
I
not.
think the Tuesday and Thursday sessions were 3 hours, right?
Yeah, Tuesday and Thursdays are definitely 3 hours. Saturday, Sundays were initially I said 4 hours, but I was getting a lot of feedback on say sometimes 4 hours become too much, and they wanted to have three, but then add additional days on that. But we'll see that. Okay. Over to you, Ramesh. Let's continue from here. Yeah,
Okay,
because
all
we
right.
will get more time to practice. That's right, Pramod. But then there'll be we'll have more days as well accordingly. Over to you, Ramesh. Let's continue here. Thanks.
Yeah, sure. So let's discuss about the containers basics funda concepts. So earlier, what people used to do something like this, right? Put the this was a basically virtual machine, not virtual machine. This is your bare metal machine, and in the bare metal machine, what you have hardware. So you used to install the operating system here. Consider this is your operating system, and on the top of the operating system, you will deploy the hypervisor, right? So that is hypervisor here. Let's say this is hypervisor. So what is hypervisor? Hypervisor is a software which talks to the hardware through operating system. Directly, you can also put the hypervisor on the hardware, or some of the hypervisor which are available, they are put it on the operating system. They are not directly installed. And on the hypervisor, we used to create a multiple operating virtual machine. This is my one virtual machine. This is another virtual machine. I can have multiple virtual machines, right, guys? Okay. Now, sorry. And what this virtual machine used to have, they will have something called as operating system inside it. So again, there will be operating system. Then there will be some libraries and binary files here. And on the top of that, there will be application. So this is your virtual machine actually. This is your one virtual machine. So inside that you have operating system. We have a diagram for this one. We have after that we have binaries and libraries. And top of that you have the application deployed here, right? Like this one. So similarly on the another virtual machine you can have operating system, libraries and application on the top of that. This is the scenario when you deploy the virtual machine. But basically what happens in the virtual machine, it becomes a little bit bulky. You have to install complete operating system. Maybe a 2 GB, 4 GB or 8 GB operating system is residing on this virtual machine. Then top of that, all the binary files and applications are there. Okay, so what actually happens in the containerization? It is similar like this one, but there is a little bit difference. So let me show you the difference, guys. So you have, this is your bare metal machine. Okay, and on the top of the bare metal machine, you may have a hypervisor or not required also. You can have operating system directly as well, hypervisor or operating system. So this is my host machine. On the top of that, you have operating system. On the top of that, operating system. And on the top of that, let's say that you have one more layer that is called as container engine. There are various types of the engines are available. There are various organizations such as Docker is there, Podman is there, you have Rocket is there, LXC is there. There are so many Docker engines are there. CRIO is there. So these are the container engines. And on the top of that, you will have a lightweight container. Okay. Now, how the container is made up of? Container is made up of from the image. So building block of the container is image, right? So you will have this image inside it, and from the image you will create a container. But what that image contains? That image contains very thin layer or basic requirement of the operating system, thin layer of the operating system, very thin layer, not bulky operating system. Because you need to install something, so you can have a thin layer of operating system, very thin. And on the top of that, you can have whatever the binaries and binaries required. Let's say this is your binaries and libraries, you can say. And on the top of that, you can install the application. So this is your application. So, but what is the advantage of here? What is the advantage of the container over the virtual machine? So first thing, in the virtual machine, you require a lot of time to booting. It may take a lot of time for booting. This is one thing. Second thing is bulky, right? And here you can say this is not a bulky. This is in the MBs, 100 MBs, 200 MB, 500 MB, not more than that. It is very thin and it quickly boots up. It boots up in the seconds also. So that is the difference, basic difference between the container and this one. You can use one image to create a multiple containers, right? So if this is a host, this is operating system. On the top of that also you can have a virtual machine. In the virtual machine also you can put this one container. So let's say that you have one virtual machine, inside that you have multiple containers as well. So if you have hypervisor. So let me show you that one diagram which you have. This is the diagram I would like to show.
Just one question I would to take, if we go back to the previous drawing that you did, Ramesh. So there was a question Sumanta was saying, so we are drawing a diagram saying that operating system and a hypervisor. So you get two type of hypervisor, type 1 and type A, type B, or type 1 or type 2. So where one type of hypervisor, like you have a VMware, you can do it on top of operating system, but you can also install directly hypervisor directly without any operating system and then spin off. That's a type B or type 2 use interchangeably. I'm not on my top of head, but hypervisors of two type. One you can install on top of operating system like VirtualBox or VMware, and another one is you can directly do like Zen hypervisor and other things as well. Yeah, so in second one, we are just doing without your right. We are not doing in hypervisor. We are not doing on a VM. We have a host. On that we are doing operating system, and on top of that we are deploying it. Now guys, can you unmute yourself and have any questions so that we can answer, because that question comes again and again.
So I'll tell you one here. This can be your host. On the top of that you can have a hypervisor. So hypervisor is something which you say that which directly sits on the hardware. Okay, so that is called as the hypervisor. Like, let's say there is one hypervisor which is something ESXi.
Yeah.
ESXi directly sits on the hardware. It doesn't require any other operating system. So it is actually hypervisor, and all other hypervisors are called as a para hypervisors or para virtualizations. And on the top of this, you can create a virtual machine.
So I have a question here, Ramesh. So you said hypervisor is being used for communication between the operating system and the host.
Virtual machine.
Sorry, what virtual machine? Okay, operating system in the virtual machine. So in the second diagram where you have there is no hypervisor, you have mentioned container engine. So Docker will play the role of hypervisor?
No. We don't require a hypervisor here.
Oh, we don't need hypervisor.
Yes, container can be directly deployed on the host machine on the operating system directly.
Okay, and how the communication will happen?
Samantha, there are three things. No, okay. So first of all, you need container. Okay, container will run on an operating system always.
Right.
Okay. Now, that operating system can be coming directly of a host on that you installed operating system, right?
Right.
Now, let's suppose you come in a virtualization world, so you can have a machine. On top of that, you have operating system, and as left hand side para virtual hypervisor, which means that virtualization like VirtualBox or VMware, they need an operating system. On top of that, you're installing a hypervisor. On top of that, you're creating a virtual machine, and then you are deploying container on top of that.
Right.
Okay, that's option 2. Third option is you directly have a hardware, you install hypervisor on top of that, and then you're creating a virtual machines. Okay, so that hypervisor will be now virtual machine need a hardware or interaction with the hardware like CPU and memory. So the virtual machine will talk to hypervisor. Hypervisor will go and do those hardware resources like CPU and memory to the virtual machine. So
okay, got it.
Yep.
Atul, my question is, in the second diagram, actually, in the second
middle
diagram, middle one, you are like, deploying the Docker container directly on the host operating system, correct?
Yep.
And then again, you are creating one virtual machine, and there again, you can deploy that application. Is that right?
No. So
what is that pink thing actually? Pink process.
Thin OS, hold on that. It's coming. It will become clear when we talk about imager. For the time being, assume that there is no thin OS. Okay. This is a very lightweight image that will be sharing the kernel. So it's a operating system kernel which will be shared by the underlying container
engine.
Container engine, yeah. So assume maybe for the time being, remove that OS, Ramesh. I think otherwise it'll confuse. When we come to the images, then will become clear. Okay. So remove that thin layer of OS, which is on a container. Okay. Assume you're not aware of this. Okay. When we come to the container, we'll make it clear. So actual operating system is when we say there'll be actual operating system where you have a full-fledged kernel. That is actually operating system. What happens is then in kernel there is called as names, like within Linux kernels or nowadays on Windows kernel as well, you have something called as namespace. Sorry, I have a background, another thing going on, so sorry for that. If you see a little bit background noise on my side. So what happens is there's something called as namespace, which will give you my process ID, processes, or maybe a network or storage, all those things separately. That we call it is a thin layer of operating system. Okay, assume that's not there. So on top of operating system, you have a container, and container will have, when I say container, like for my Nginx container or my .NET container or my PHP container, that will have libraries, applications, and a very thin layer of operating system. Assume for the time being you don't have that. We're not talking about that operating system because it will confuse you. We'll explain that when we come to images. That time we'll explain you that point.
Okay, thank you.
Okay.
And in the
So
in the third diagram, you have directly hypervisor on hardware without operating system, correct?
That's right. So
and
now
then you
on
have
top of
VM
that,
on that.
VM. So in that we are going to install an operating. From this hypervisor, we're going to create a VM. That VM will have my operating system. It could be Linux VM. It could be Windows VM.
Okay.
On top of that, on that Windows, on that VM, I'm going to install container. and then run my container 1 and see. So if you don't mind, can you put on that VM, can you install a container? Ramesh, on this, yeah, below container, there'll be operating system. So there'll be a container, no, on.
Yeah, right.
So just below
just
C1,
a
C2,
last
there'll be a,
question.
yeah, so there'll be a OS here.
That thin operating system actually, that will automatically will be created by like the cloud
Container.
provider or container.
No, nothing. We are not talking cloud anything here. The thin layer will be inside the container itself. When you start a container, so when you start a container, you will need a base operating system or a very thin layer of operating system, which could be like we'll see when we say Alpine or Ubuntu or a process on which a layer on which my processes can run.
Okay. So it is automatically created.
For the time being for
Okay, thank you. Enough.
Yeah, I will just clear this thought process, guys. Don't worry about it.
Oh, thanks. Yeah. Any other question from these three diagrams, guys? Because this is important to understand. You have a in a nutshell, what we are saying is container engine will always run on top of an operating system. That operating system could be Windows. That operating system could be Linux. That operating system could be Mac. In the lab examples, we are doing it for Ubuntu thin operating system, Ubuntu. Not thin. Ubuntu operating system, but you can do it on Windows. You can do it on Red Hat Linux. You can
Mac.
do it on Windows. Okay.
Absolutely.
Any other question on this? No, I'll leave it. Let's continue from here. Over to you, Ramesh. Sorry to interrupt because I was very confused on this diagram initially when you used to explain me, Ramesh, and so I'll leave it to you. Back to you.
I hope that this is clear to everyone now, right? Okay.
Hey Ramesh, are you able to hear me?
Yes.
Yes, Mayur.
So Ramesh, that OS you talked about in virtual machines, is that OS has to be similar to what we have on the physical platform?
No.
So there is no codependency, something like that, right? It can be different.
No,
Means we are
right. Yes.
Okay.
I can show you here. This is my virtual box is here. Now this is a Windows box, and I have to install a lot of operating systems here. This
Okay,
is my
those are
local.
Red Hat and all.
Yeah, Red Hat is there. Ubuntu is there. I can install Windows also here.
Oh, okay.
Right.
Okay. Yeah.
And my base machine can be Windows, and on the top of that, I can install Linux also. I can install Windows. I can install Ubuntu as well.
Okay, got it. Yeah, thank you.
Virtualization, it can be different. You can have multiple operating systems, various operating systems. Okay. Cool.
Ashish,
So,
about your question about how this ThinOS is different from OS, hold that question when we come to images, and that time we'll discuss it. And we'll open up and we'll create a thin layer of operating system and image within image. So hold that question until we come to the images. Yeah, over to you.
Yeah,
Ramesh, that VMs which you indicated, right? This VMs are the limitation of VMs are same as the even for the cloud VM also, or is it something other way?
no, it is same. These virtual machines are available on the cloud as well as bare metal machine. They are same. So limitation is virtual machine is always bulky, right? But there is an alternative for the virtualization machine is the containerization. So if you have a physical machine and you don't want to use a virtualization at all, you can still deploy the containers.
Okay. So you're telling the limitation of VM irrespective whether it's in OS based or the any Amazon VM or anything, the limitation lies the same here. Okay.
Yes, it is same one. Yes. Okay. So now you can see this, whatever I have written on the diagram, I have drawn it. Same thing is now shown you a pictorial, very nice diagram is drawn here. You can see. So you have physical server. On the top of that, you have hypervisor. Then this is your virtual machine, right? On the top of the virtual machine, see guys, you require more utilization and everything. You require more GB of the size, and bottom type is definitely more also here in this case. But here in the Docker containers, containerization, what happens? You require a physical server or virtual machine. On the top of that, you require operating system. And on the top of that, you can deploy the Docker engine. It is important. And you can have this. These are the containers. In containers, since they are very lightweight, of course, their utilization is very, very thin. You can assign a millicore of the CPUs also to the containers. Very small amount of the CPUs can be allocated to the containers. Its size is really small than the virtual machine. I will show you that in some time. We'll be creating a container from the image, and so you'll see that the container size is hardly in MBs, 100 MB, 200 MBs, not more than that. And you will not believe that when we start the container starts in Jiffy. It hardly takes 1 second or 2 seconds to start, and I will be able to show the application also. And this is the basic difference between what is virtualization and the containerization. So containers are very fast. You can create multiple containers from one image. Same containers can be created, multiple containers can be created from the same image. Its utilization, hardware computing resources really required is very less, and the size of the container is very small, right?
So, Ramesh, this is Vinay. So that
Mhm.
means if we want to do the containerization, then we need the Docker engine.
Docker engine is the main part, yes.
Okay.
Without container engine, you cannot deploy the containers.
Because
That also,
without Docker engine.
yes.
Yeah, okay, thank
Docker, let me put it in another way. So we are covering here Docker, but please keep this in mind that there are variety of the container engines available. Okay, one of them is a Docker engine. There is another one which Red Hat has developed is a Podman. There is one more is that is called as a CRIO. A Rocket is there. So there are different companies which are working for the container engines, and one of them is a Docker. Okay, so what are the containers? Host OS shared by all the containers, of course. Application is decoupled from the operating system, so it is not dependent on the operating system, which is a base OS. Startup takes few milliseconds, not I have said seconds, but it takes few milliseconds. And packing is not a bulky; it is very lightweight. You can see here there is all you can put it on the bare metal machines. You can put on the cloud, right? Then there is a containerization platform, and on the top of that you can create a services. You can deploy this app one. You can have this is your in another one. You can have in another container you can have service A and service B running in one container as well. You can run multiple services in one container also. That means multiple services in that you can have multiple websites. You can have multiple applications running in one container too. That is also possible, but don't
So
try to
Ramesh,
make it bulky.
Ramesh, I have a question. So let's say I have a VM and there is a Red Hat OS running on it. And my understanding is the container is derived from image. Let's say my image is based on HPUX. And when I spin up a container from that HPUX image, would that container have a thin layer of HPUX and then pins and application on top of it?
Oh, that is a very good question. Actually, these are the all proprietary software operating systems, right? HP Unix and IBM UX and Solaris. So first, probably that will have a constant. So we have to see that whether HP Unix image, which will be able to run in the container or not, or their support for the container need to be checked. But I'm damn sure if it is a let's say operating if it is let's say image created from the unique Ubuntu or Linux or something like that, Windows, it will run properly. But for the proprietary software such as HP Unix, Solaris, and IBM X, I will check it. I need to check whether the container environment does support it or not.
Thanks so much.
Okay.
I'm trying to understand.
Yeah, guys. Another, as I said, hold the questions till we cover a complete to a container. Let's take we'll come to that point. Let's complete this part section here, and then we'll take the questions, please. Yeah.
Okay, guys. So this is the containers are lightweight because they don't need the extra load of hypervisor. Run directly within the host machine's kernel. Run Docker containers within a virtual machine as well. Develop your application and its supporting components using containers. So containers are really cool thing happened in this IT world, guys. They're very lightweight. And container is the basic unit of distributing and testing your application. So whatever you want to do, you can put it in the this container, and you can give it to the same image can be given to the developer, same image can be given to the tester, same image can be given to the on the pre-production box also once it is confirmed that it is running fine. Right, so reproduction of the environment is really very really cool thing in this containerization. You don't have to worry about what will be the environment environment which will be available on the production, what will be the on the test server, or what will be on the container, whether the CPU less, RAM less, right? Computing power can be different, but since it is isolated, decoupled environment is there in the container, you can easily ship your containers from one host to another host as well, using the different containerization tools, right? That is the beauty of it. Okay, so now what is a Docker? Docker is something, it is a container engine, and if you want to create a container, you need a Docker container, and then some settings are required, and you can put up the application inside it, and you can create a container out of it. Yes, right. So you can see this is the containers you can create, and you can put the application A inside it, application B inside that, application C inside this one, and we can use container technology called as a Docker to create application with the help of image, and that it can be loaded into the container. So what container will have? Container will have image. This is one thing need to be understood, and that how that image is created, that I will try to explain in some time. Okay. So now, what are the features of the Docker? So it is application isolation and security management. This is one thing. You can have one application which is on the web-based Apache, other can be on the Nginx platform. I can have, so on one virtual machine, I can deploy multiple containers with the different service types as well. And one container's application will not come to know what is there in the another container. So completely isolation and security management is done. Yes, of course, it has a multi-tenancy. Simplified configuration. It is very simple to configure. It is really cool. It doesn't require much efforts to configure the container, and because of that, it increases the productivity. And that's why in the CI/CD also they use this kind of containerization very well. So this is the DevOps, right? So why this CI/CD is nowadays possible, effectively possible, because of the introduction of the container. That is also one of the feature of the Docker containers, and rapid deployment is another feature of the containerization, Docker containerization. Okay. Now, who are the industries using Dockers? Right, Docker is everywhere, right? Containerization is everywhere. It is in the healthcare, in information technology, finance, aviation, and telecommunication. I see everywhere this containerization is now being used. So, introduction to Docker. Let's say Docker is a platform, as I told you, that it is a container engine, platform for developers and system admins to develop, ship, and run application by using containers, right? So you can put your image inside. What developer has created a nice code. Code has been from the code you can create the image, and from the image you can create the container, and then container can be shipped anywhere. So as we discussed earlier, that Docker helps the user to quickly assemble application from its components and eliminates the friction during the code shipping, right? So this is the one very good advantage. And Docker aids the user to test and deploy the code into production. So this is one of the tool available here to deploy the application very quick and faster. And what are the Docker functionalities? Docker provides a platform for the user to deploy the application into production environment as a container or an orchestrated service, test the application, develop application and its supporting components using containers. So all the life cycles of the software development life cycles, SDLC, are supported by the Docker, right? Yes, this is something which we need to discuss now. Underlying technology, it has namespaces, right? Then it has the, I will explain you what is a namespace clearly, guys. So the PID, net namespace, IPC, MNT, UTS namespace, all these are the namespaces. I will just come back to this one. So what are the underlying technologies used by the containerization? Let me explain you on the page here. Let's come back here. Then I will go back again to the slides. Guys, whenever you, let's say this, whenever we want to start the container, so container use the different underlying technology. So what are the technologies? So first thing is a namespace. Please try to understand this, guys. What is a namespace? So namespace, inside the namespace is nothing but a logical space where container will get created, right? It will be created by using this underlying technology called as a namespace. So what is a namespace? Namespace is nothing but PID. One of the component which is from the namespace which is used is a PID. PID stands for process ID. Okay, so what is a process ID? Whenever you start any process, that process comes into RAM. When process comes into RAM, that gets one unique ID that is called as a process ID, right? Then it requires a network. So who will provide the network to the container namespace, right? So it will require a network. So there is a NAT namespace which is available that is given, right? Then there are a lot of calls goes from CPU, RAM, operating system of the container application, and a lot of calls are happen from the RAM to hard drives. That is called as an inter-process communication, that is IPC. So this is another component when we create the container. So this container gets these components, right? It requires a process ID. It requires a network card, that is IP address and everything. Then there should be a communication between the processes, that is inter-process communication. You need to have volumes attached to the container, right? Partitions, where it will hold the application for some time. That is provided by the MNT or mount. It is called as a mount, right? And it is also called as a yeah, right. These are the some of the important underlying technologies being used by the as a namespace while creating the container. So it requires PID, network, as well as IPC, and mounting the different parameters, file systems. Okay, this is required by the container. So that is provided by the namespace. Now, another important thing that is provided by the provided as underlying technology, the container from the native operating system, and that is control groups. So what is control group? So control group is something, nothing but that, let's say that, or there is one, there are two more, let me explain. There is one is SE Linux and another one is SE Comp. So these are the underlying technologies has been allocated to the container while creating the container so that it will be managed properly. So what is control groups, right? So let me explain you the control groups here. So it limits an application to a specific set of resources, right? So control group provides the hardware resources. How much CPU and RAM should be provided to the container? CPU and RAM. All the computing power, all the resources which need to be assigned to the container, how much they should be, right? Whether it should be given more when application demands, container application demands more RAM, so automatically it will increase, or maybe let's say that it requires less amount of CPU, then how it will. So the resource allocation for the container is controlled by the group called as a controller group. So these are the two important terminologies. So namespace is basically
Ramesh, all these are all these are provided by the Docker engine, or who provides these things, control groups and your all these things actually? Who is the provider?
Right. This is the base host provider. Host provider is there. Host operating system provides these parameters to the container engine, and container engine helps them to put into the container.
Okay. And they are unique for each container provided by the host, right? Separate
Correct.
PID,
Yeah.
separate NAT, separate IPC, separate mount for each container, right?
Right. Okay, I'll just discuss about, I will show you this in some time. Let me complete this
Okay.
SE Linux and SE Comp. So I think it will not break the flow. Okay, now SE Linux is something which is very interesting, right? SE Linux is also something like that. Let's say SE Linux is one additional feature of the Linux file system, or you can say that whenever we create a files and folders, along with the RWX permission. Okay, do you know RWX permissions? Let's say this is my Linux machine. Okay, it has got disconnected. Let me show you that. Yeah, now see here, guys. So basically, this might not have a SE Linux present on this box. So there are permissions which you can see. Let's say there is one file called as this file is there, and you see here these are the some of the permissions, RWX permission. Along with that, there are certain permissions which you see at the question mark here. There will be additional permission at this location. These permissions are like user, role, target, and severity. So what is these are the additional permission, and it is called as a MAC, that is mandatory access control permission. So whenever we have SE Linux enabled on the host machine, and if you are sharing some files from the host machine to the container, then SE Linux will come into picture and it will block the permissions. Then you need to inform to the SE Linux that please allow the files and folders to be mapped to the container. In short, if any container wants to use files and folders of host machine, when I say host machine, that means you are where the containers are, you are starting the containers, that is host machine. Okay, so you need, if you want some files and folders to be mapped to the container inside the container, then host machine operating system, it has a SE Linux. Then you need to inform to the SE Linux, please allow the files and folders to be accessed to the container, inside the container. Otherwise, SE Linux will not allow you to assign the files and access the permission inside the container. It is additional security on the files other than the RWX permission. Right? So that is SE Linux. SE Linux controls the access of the files and folders to the container from the host machine. And what is the SecComp? SecComp is another feature, underlying feature being used by the containers or assigned to the container, so that container should not control the base operating system. What I'm saying? If think about the situation that this is a container running here, and this container is shutting down the operating system, what will happen to the entire all the containers which are running on the they will also get collapsed. So none of the containers should control the resources of the operating system or resources of the host machine, and that is managed by using the SecComp feature. So these are the important features which get assigned to the container when we create the container. So this is called as the underlying technologies. Namespace, control group, SE Linux, and SecComp. That is very important to keep in mind, guys.
One more thing I will suggest you is, if those who are not coming from Linux background, I would suggest you recommend to watch this recording one more time tomorrow or later in the week and make notes. And if you have any questions, don't worry, we'll cover again in future if required. But this is first time might sound complex, especially for those who are not coming from Linux background or those who are not system administrators. But it's not a rocket science. Again, if you don't understand it right now, don't worry. When you come to once we go a little bit more into, probably might start understanding. So don't worry if you're not getting 100%. And first thing, when you listen these things first time, it might be a little bit complex. Yep.
So one question actually, can you go back to the previous slide, Ramesh, actually? Because I was asking. So now all these features, I will say, like, or like, utilities, whatever you say, are provided to the container by Docker engine?
Through operating system. These are the underlying operating system features.
Okay.
Through the containers, through the container engine, it is provided to the container.
Okay, good. Thank you. Thank you.
Okay. Welcome.
Can you, Ramesh, can you just repeat SE Linux and the CCOM part of it, just high level? That's it.
Okay, SE Linux is the additional.
Firewall.
Which one?
SE Linux is just like a firewall, right?
No. Firewall works on the ports and the ports, basically IPs and ports. But SE Linux works on the files and folders. So we have the basic permissions read, write, and execute on every file and folder in every operating system.
Okay.
But additional features, additional permissions are provided by this SE Linux. Basically, SE Linux stands for Security Enhanced Linux. This is actually developed by the United States Agency of the United States, USA or something like that, United Security Agency of United States, and the Red Hat. This is very powerful concept. Let's say that if one service is there which is trying to access the files, let's say Apache is there, let's say HTTP service is there, HTTP service is trying to access the HTML pages which are kept at the location called as a var www.html. If SE Linux is not present, Apache will directly go to that location, it will pick up the files and it will display to you. But if SE Linux is present, then you need to inform to the SE Linux that Apache will come and we will pick up the files from this folder. So it is an additional access control layer applied on the files and folders. Even if you are trying to change the port number of the website, let's say you don't want to run the website on the port number 80, you want to run on the 82 number port, that is a non-standard port. That time you need, if the SE Linux is running, then you need to inform to the SE Linux, look, there is a new one more new port has come, and that is 82. You have to if any request is coming on the port number 82, please accept it, allow to accept it. So SE Linux is an additional layer of security provided inside the operating system in the Linux. And SEComp is nothing. SEComp is nothing but it is a service which will, or it is a feature of the underlying operating system which will not allow containers to take the control of the host operating system. That is a SEComp feature. I hope that is clear.
Ramesh, I have a question here.
Documentation link on Linux and SEComp on the group WhatsApp group.
Yeah.
Ramesh.
Yeah, Surendra, we hold on. We'll take the question at. We're taking questions at each logical point only. It's not. This topic is a little bit complex. Might sound a little bit. So don't worry about it, Surendra. Let's take the questions, please. Yeah, go ahead. Sorry, that was someone was asking question. I forgot who was that.
So why we say that the containers are going to take the control on the host?
Yes, good. So if I access the host machine from the container, let's say that this is my container. This is my container. I have logged inside this container, right? And if from the container, if I shut down the operating system, host operating system, because it is everything is IP based, right? I can have a communication from this both ends. So if you try to do that communication and if shut down the operating system, or if we change something from the operating system layer, then entire other applications will also get impacted. So that is why containers should not control the operating system, host operating system. And for that one, you can use SecComp feature.
So there's one more thing. What is that? A Selinux is what we give authentication part, right?
It is basically security enhanced Linux. It works on the files and folders very effectively. Also on the ports. Basically, if you want to access the files and folders, then you need to inform to the SE Linux that this service will come and this will access the files and folders.
Where we are going to mention those, like in coding, that these are the files are coming, these are the services, those who are going to come and access, right?
Yes, right. You need to specify in the coding.
Mention everything in code.
Yes, right. It is not a coding feature actually. You need to, whenever you are deploying the application, let's say Apache application, it is an operating system layer feature, right? And that you need to fire the commands on the operating system, or you can inculcate that commands in the coding as well.
Okay, got it. Thank you so much.
I have a question. Is that SCOM, do you need to enable to work that feature, or is there any way?
It is by default, it is enabled when you install the operating system.
Oh.
Yeah.
I have a question, like when we are doing some kind of patching activities on the base OS, How
Mm-hmm.
about the containers and the Docker? Will it get effect, or how it is going to be? It's like the regular environment, or is there any special thing which is going to be act here? Like when we doing some activities on the base OS or the base
Yes, yes.
level of hardware.
Right. No, this is really good question actually. Basically, SC Linux, basically the operating system features which are impacting the containers. Okay, so we need to check the compatibility with whether everything is fine or not. So otherwise, whatever the application is running inside the container, that is not going to impact the whatever the changes you make in the operating system of the host. It is not going to make any. Only thing is that if it impacts on the container engine, if it is impacting on the container engine, then it will maybe probably create a problem in running the containers.
Okay, say for an example, if we reboot the base OS, so what will happen to the containers and the applications running on it?
Very good question. Actually, you can write or you can enable the systemd process. There is a systemd process in the Linux. Okay. If at all, if anything is going wrong, or if anything goes wrong in the host operating system and system is rebooted, and if you have enabled the systemd process for the containers can start automatically.
But where it will get start and where it will get run, I can't get this here. If the base OS is getting rebooted, so how the
Yeah, so
container will?
it will be no. So once okay, so if base operating system is gone, all the containers will go away. Okay, will not be
Yes.
available. But when it comes up, you want them to be automatically started. You can control that. But if base OS is gone, on the underlying on which container is running, if that operating system is gone, you're gone. You lost all the containers. That's why you run multiple machines for that.
Okay, got it. Thank you.
Now I see a lot of questions are coming and saying we are taking questions, guys. This topic is important, and don't worry. As I said, we will not leave you. But this, when we say topic, as long as related to this topic, and which is otherwise it will confuse if we go move forward and if you don't answer here.
I have a
Because we are still,
question.
yeah.
We have the OS on VM, the container, right? And we have the base OS. Okay, is there any relation which the version of these OS? Is there any dependency?
No. So the when we say the very thin layer, again, I don't know to come because it could confuse right now till we come to the application and containers. That operating system will be just on which that particular process runs. So for example, you have a .NET application, you will pick a thin layer of .NET. If you have a Linux process or a process or your application that needs to run on a Linux based kernel, which you'll put a thin layer of that particular Linux version. So depending on what type of application you have, you'll be creating a container using that thin layer, and that will, again, I don't want to confuse people because I keep repeating that thing and we have not even discussed what is the thin layer. That will become clear when we go to the images. Yeah.
Okay. Guys, just hold on for the questions. I'll just come. Your doubts will be clear. Don't worry about it.
Okay, so let's do one thing then. In that case, Ramesh, let's move on, and then we'll become when we come to that point, the minute we install Docker and I think container, then will become much more clear. Yep.
Yes. Let me do that one.
Yeah, I think that will be the better one now.
Okay, cool. So let me now. So I hope that you got
saving them as well. Yeah, I hope you're saving that again. I'm asking
yes,
third or fourth time.
No, it is important because this is important for me also and for participants also. We can give it to them as well if you require. I have this image. Okay. All right, friends. So let's move ahead. So we discussed about the underlying technologies. Okay. So let's deploy the Docker engine and then come back to the slides. I think that will be better, right? Okay.
Yeah, I
So
like that one. The last time you did it, it was more you install and then you explain from the do you mind do one thing? Can you convert this and then coloring and then make it white? Do you prefer this or white over black text? Yeah, reset. First is 18 font and then system colors. Like make font at 18 and then go to system colors under colors. And, no. I'll tell you. No. Go back. No. Don't change anything here. So if you.
This is what you want, no?
Okay. Now I wanted the other way: white text and the black. It says
no,
use system.
Sometimes in the scripts white text are there, so it doesn't make
Okay,
good.
fair enough. Fair enough. Let's live
If
with
you
that.
write
Yeah, let's
something,
continue with this.
yeah. Okay. All right. Okay, guys. So this is my Linux box. This is installed on one of the cloud platform, and this is something how to check the operating system. You can use the command on which operating system you are there, and look at this. I am on the Ubuntu. This is my 2004 to LTS system, right? And now we need to install the container on this one. So first of all, this is the OS.
Ramesh, this is a virtual machine that you have created somewhere.
Yes, this
And
is a virtual machine.
how do we come to this page? I mean, is
Oh,
there any guide
Okay,
for
yeah.
that?
So Vipasha, what I'll do is we have a lab on our module 2. I think mod team will share that. You'll be it's a good point. And if you want to try it out, how you're going to do it, we are going to you're going to go to Azure Cloud. You'll create an account in Azure Cloud, free trial, and then you'll go to and create a Ubuntu machine, and then you connect using Putty. How to create an account in Azure? How do you connect to that machine? How do you download Putty? How do you do all those things are covered in that lab. Follow that lab. If you hit any problem, ask and inform in WhatsApp group. Ayush will be there. Piyush will be there. They'll be helping you answering any questions. Yeah.
no. Yeah, sure. And
Over
in
to
the
you.
next session, I can spend 15 to 20 minutes, guys, in
Yes,
case you
please. Yeah.
have the environmental and access issue, that how to deploy the machine and how to access it. I will definitely help you with that one. So don't worry. So what the way you should do now, the practical way is like this one. You can see normally I explain the concept, then I show the demonstration. Then the commands will be copied in some file and it will be given to you through the K21 it will be uploaded on the web portal. But however, I will suggest you guys you can perform the practicals along with me when I'm doing it. If at all you have a good if you want to perform, otherwise you can watch the session and then you can also perform the activities again later on. If it is up to you how you are to manage. But if anybody would like to work with me, I'm more than happy to do that.
Are you working
But
on
I think
Windows or
what I would suggest you is watch and understand and see what he's doing, make a note, any doubts, ask, and then do it. Because if you're doing it parallelly, you might miss some of the things and there are a lot of
Ah,
golden nuggets which are going to come from these topics, or which is going to give a demo. He tells a lot of things, interesting things behind the scene, what's happening, why they are happening in that way, where to look for those. Those are very interesting. My session to you would be watch him, perform him, let him do it, watch the recording, and then play it as we're going to create labs as well for these because they are very interesting on that. Yeah. So that's my suggestion. But feel free if you want to do it parallelly, do it, but on your own risk. Over to you.
right. Okay, guys. Host name and let's say I am setting up this host name for my understanding, guys. It is nothing to do with this. Okay, so always have some good, nice name to your computer. Always give the name. So you will recognize that because you should have this habit of keeping the host name properly. When we start the Kubernetes, there will be multiple nodes. Then you will get confused. Which one should I use and which should not? Okay, we'll do that one. So first of all, you need to install the Docker, right? So how do you do that? Okay, this is Ubuntu machine. So I need to use which command? apt install docker star and -y. Why I'm using a star
Ram-
here? All the
Ramesh, one
features.
question. That
Mhm.
name that you have,
Sorry,
I
Vipasa,
mean,
do you mind?
replaced
So
the.
Vipasa, sorry, do you mind? Can you ask question in WhatsApp group? We'll take that. I don't want to break this flow right now here. Yeah.
Yeah, it's a very basic question, Atul. I mean that IP address is for the virtual machine that you have created on Azure account, is it?
Correct,
Yeah, it could
correct,
be Azure,
absolutely.
it could be local machine, so it
I
doesn't
got
matter.
it. Okay.
Anything. No
It
problem.
could be anywhere. So it's a machine. It could be running on Azure cloud. It could be AWS cloud. It could be Google. It could be on my local laptop. It's a machine. End of the day. Yeah.
Okay. Yeah.
Very good question. Actually, you are asking very good, nice question. See, actually, we see these are the lot of machines are there now. If I want to use any one of them, I can just have one IP address and I can access it from the Putty. There is a software which you need to use, a Putty software, and it is a small software which you can be downloaded. Okay, guys. And here you need to put the IP address. Once you put it here, it will actually right. Yeah. Now, so installation is almost done. It is a very easy and very quick. So only two steps are there. One is I have updated the system by using apt update command, and second command I have installed apt install docker star -y, and here you go, you got the installation done. If you want to
Hi, Ramesh.
specifically install the version, you have the version, you can you -y stands for you can that is yes for that, right?
Hi, Ramesh. Santosh here. But why you chosen this Ubuntu OS?
Sorry. Guys, I'm a little bit not. You can ask question in WhatsApp group. I'm replying everyone's question, because what happens is the minute you do, it might break the continuity. Please ask question. Santosh, I'm not against you specifically. I'm just giving it to everyone generic. Okay. Please let him cover, or let's focus on this. Ask question in WhatsApp group. Oh, sorry, not WhatsApp group. Ask questions here. I'm answering them. Over to
Thank
you,
you, guys.
please.
Thank you. Please just hold on for some more time, guys. We will answer your questions, please. Okay, so this is the two commands which I have used to install the Docker. Once you install the Docker, then you have to start that Docker, right? So can you, and to start it, we have to use command systemctl start Docker. This is the one command you need to fire, and you need to make sure that you enable this installation so that whenever next time you reboot the machine, automatically it will get started. So these are the two commands you need to start. It is used for starting the Docker containers, Docker engine. And how you can check whether Docker is running or not, you can use the command docker version, and you should be able to see what is the version you have installed on this machine. So it is basically 19.03. Okay, cool. Now, if you want to see whether the Docker is running or not, you can just use simple command systemctl status docker, and look, it is running. Okay, so what are the commands I have used? So very simple, very basic commands used to start the containers. Look at this history. First of all, I have updated the system by using apt update. Then I have used command apt install docker, right? And then we have started the Docker engine. It is a daemon basically. And then we have enabled so that next time it will not, whenever we reboot this box, it should automatically start. And to check the version, we can use this docker version command. And this is to check whether everything is all right or not. So once you complete this one, then we can use command. Let me clear the screen. And guys, I will copy these commands for your reference, and I'll keep in the notepad, and I will give it to them, Piyush or somebody, that so they will upload it for you. So don't worry, all these commands will be available for you. Okay. Now, once it is installed, then you can use command docker ps. So this command will help you to understand whether any container is running or not, just checking. And another command is the docker images. So docker images command will help you to find out whether there is any image or not, right? Once you get, okay, so once you download the image, then you can create a container. So basic building block of the container is image. Oh, okay, so image, but where I will get this image from? Where are these images? So these images are available on public repositories. So do you know the public repositories which are available, public repositories such as Docker Hub? Another public repository we can use that is called as a GitHub also you can use. You can use Red Hat repositories, and so many repositories are there. You can create your private repository on the GitHub or Docker Hub or Red Hat. Red Hat doesn't allow you to create private repository, but Docker Hub and GitHub you can do, and you can download the images from that. But how do I find it? Which image I should download? Where to see this? So there is specific commands are there. You can also go to the Docker Hub to check the images. So I will show you first of all graphically quickly, and then also I will show you command line how to check the images. So we are working on the images now. How to search images? So let me go to the Google Docker Hub here. So let me search Docker Hub, and this is my Docker Hub link.
And by the
I
way,
am on the
Docker
Docker.
Hub is a repository to store all the images. Sorry to interrupt, Ramesh. I thought that question, before that question comes, I'll tell you. Docker Hub is a repository to store all the images. Over to you, Ramesh.
Yeah, absolutely. So repository is the location where we can keep the images. Repository can be another location where you can create your RPM files. A lot of things are there. So in short, repositories are created to keep the images. Cool. so that anybody can access. Now you can also access the images which I have created in my repository. You can also access it. Okay, guys. So I would like to access HTTPD. I want to see, is there any HTTPD image? Yes, I can see it is an official image also. Okay, I want to see something called as Nginx image. This is another Apache, another HTTP source. Yes, I can see there is an Nginx image also. I need to see whether there is MySQL image available. Yes, I can see I have MySQL image also. I want to see where is my MariaDB. Yes, I want to see here. Is there any MongoDB related any image available? Yes, I can see here Mongo related is there. Oh, PHP is my favorite subject. Is it there? Yes. Is there anything related to Windows? I should get. Can you see this? Windows base operating system images are also there. So now if I want to use, let's say, Ubuntu operating system image, we have Ubuntu operating system image also. Do you have a CentOS operating image? Yes, we have. So all these images are available, and who has created these images? These images has been created like people like you who are the programmers. How do you create these images? That is there in the other session that is called as the Docker files. We will see that in detail. Okay, so don't think about that how to create an image. We will be spending a lot of time on how to create the image. So that is a beautiful thing for the programmers, right? So this is the way we can search the images. Let me go to the one of the image called as the HTTPD, because that is understood in every technology by everyone. So this is my Apache HTTP server project. This has been downloaded by 10 million people. This is 3.4K stars are there. And let me click on this one. Once I click this, look at this. There is a more information available here. Okay, so who has created this? Is maintained by Docker community. What is HTTPD is given. How to use this image, that information is there. Create a Docker file in your project. So if you want to create a Docker file, you can create like this one. Look at everything about that image has been given as a documentation by the person who has developed this one. Everything is there. Okay, so now what I will do, there is a command also. Look at this. You can use this command here, docker pull httpd. So I'm going to copy this command and go to the command line prompt, and let me hit this command and see what happens. Now this is downloading the image from the Docker hub to this one, right? Okay, so now this image is downloaded. How to check whether image is downloaded or not? Docker images command. Look at, see, it shows that this is HTTPD repository Docker image name. Tag is latest. This is the image ID. When it is created, I have just downloaded now, right? But it is created somebody by 11 days ago, and this is 138 MB. I just want to pull one more image. Now I know how to pull the images. So I can use, I want to pull Nginx image. This is another web hosting software, guys, Nginx. So now see, it is getting pulled. Now see here, Docker images. This is also 133 MB. Look at this. This is very small images. Let me pull one more image called as my database or MySQL. Docker pull MySQL. So it is downloading the image from the Docker hub, and it is now getting installed. Not installed as such. It is getting stored inside this machine. Image is not getting installed here, guys. It is just pulling it. It will keep in the local repository where I will show you that. Docker images. Look at that. I have 3 images now. MySQL is little bit bulky, 546 MB, but HTTP and these are very, very cool. Docker pull, one more image, let me pull you, that is called as Alpine operating system. And it is very, very thin layer. It is very thin operating system, guys. Look at this. It is just 5.61 MB. So what is there inside these images? We'll see that, because we are going to create the container from this image. I don't want to use any image from this one. Let me remove some image. I can use remove image. I don't want this alpine image, so it will get removed also. If I want to remove it again, one more image, I can use RMI, and I don't want this Nginx, but I want to delete by using image ID. I can use image ID also to delete it. So this is very simple command, guys. RMI to remove the image. Okay, so let me now pull again this image, Docker pull Nginx. Guys, why it is pulling from the Docker hub only? What is the why it is not going anywhere else? Right? So the reason is that there is a configuration file here. Inside this, you can find out this registry, and inside that you can find out this YAML configuration file, and that's why it is going to this one, config.yaml file. Look at this. This is going to the 5000 port of the Docker hub. Okay, so this is important to understand, guys. Now another thing
We
is
can
that
update it, right? The registry, and we can pull from any image repository, right?
Hold on, sorry,
yeah,
Vinay. Vinay,
Yeah.
chat, please. Okay. I'm answering all the questions in chat, please. Sorry.
all right. Now if
Because what's happening is this question he was about to answer. He will answer that after 10 minutes or so when he's going in the flow. Okay, he's not limiting just to this. Yeah, please. Thanks.
okay. Now let's say that I want to pull the image from some other place. I will show you that. Definitely I will show you that. Just give me a minute. Now this image I got it now, Docker images. I have 3 images now, guys. And I can, but where this is stored on the hard drive, it has taken 133 MB, it has taken 546 MB, but where it is, if I type here ls command, I don't see any images here. I was earlier at this location, I don't see any images. So I can create a folder called as, let's say Vadapav, and try to pull the image. I know that many people like this one, but anyway, Vadapav. Let me pull the image, Docker pull. Let's say another image I want to pull is Alpine. Cool. And now see how it is now pulling it. But where it is stored, it is not stored in this local machine, local folder. It is somewhere else. So where is the repository, local repository of my Docker containers? It may be something called as images. It may be something called as containers. Where you will find that, guys? And look at this location. This location will be given to you in the command list. Don't worry about it. It is there in the cd/var/lib. Inside the lib there you will find something called as Docker. Inside the Docker you will find lot of folders are there, but there is image folder. So let me go inside the image. Inside the image you can see there is overlay 2, and here you can see there are a couple of things, image db and layer db. So let me go here. I need to go to the image db, right? SHA-256, and you see that a lot of images has been downloaded here. A lot of things are there. Okay, but let me go back to this one. CD image database. And now I will go to the metadata here. And this is a folder where you can find out the images which are, let me go to the contents. I am inside metadata, right? So I need to come back one folder and go to the CD content. This inside this one. Yes, and these are the folders, guys. So look at this, where I'll just clear the screen so that you'll understand. This is a PWD. PWD indicates on which path this image contents are there. Now look at this. So you can go to the var lib docker image overlay to image db content SHA-256. Inside that, you can find these images, right? And now, if you see the command docker images, you'll be able to see this first 12 digits of every image are reflected as a image ID. This is image ID. This is image ID. So it comes from this place. So it's a big number, 64-bit number. Out of that, just 12 numbers are coming up. This is actually your MD5 sum, guys. So from that, you are getting this 12 digits of number, initial number as an image ID, right? So the location where your images will get downloaded, this is the location. I can delete. If I don't want to delete the images by using the rm command or docker rmi command, I can delete it from this way also, Alpine. If I delete, automatically this will go away now. Now see here. Now I have only 3 images. Can I delete from this place also? If I delete the image from this place, automatically it will go from this place also. So rm, I'm just deleting this file, guys. It is a file. Image is just file here. And now see here, Docker images. See, another image is also gone. So guys, I can delete the image by using docker rm command, docker rmi command, or literally I can go to that location where the images are stored and I can remove it from that location as well. This is just for your information just now. Can you see here? This is Docker images. I can delete the image by using this command, or I can delete the image by using, I can go to that location and delete this by using this command as well. So I hope that you understood that from where we have to search the images from the Docker Hub. I hope that you have understood that how to see the images, that is Docker images command. And I hope that you have understood how to delete the images by using a Docker RMI command. Okay, cool. Now, let me show you that how I can create a container from this image, Docker images. Okay, but before that, if I want to search the image from the command line, how do I do that? Because every time I don't want to go to my Docker Hub here and search the images. Don't want to do that one. So what I will do, Docker search. This is the command. And what you want to search? I want to search for HTTPD image. It will list all the images related to HTTP on the screen. Look at this. It shows that there are a lot of images. Docker search HTTPD. It is showing that there is a HTTPD image. There are this many stars are there. This is there. And related to that, other people have also created these images. They keep it on the Docker Hub. But always see that whether it is official or not. If you use the official, if you want to use the image for your projects, make sure that it is official and it has a good stars. Okay. Now I want to search image called as, this is HTTP. I can search for, let's say, MySQL also. There will be lots and lots of images on the MySQL also. Look at this. This is my MySQL image. Yes, it is official. How many stars are there? A lot of stars are there, right? And this is description about that. I can see also MariaDB. So you can search the images from the command line also by using this command. There are further options are there, but I don't want to take that option. How to filter and how to search, how to limit them. You can do it from this place, guys, right? Now, so now first of all, what I will do. So since I have a couple of images, and you might be now thinking of that how I can start my container, how I can create one container from this image. That might be thoughts in your mind right now. Let me hit it. Docker. I will use command run. Docker run -it. All options will be explained to you. Don't worry. So what I'm doing, I'm running one container in the interactive mode. -I stands for interactive mode. T stands for terminal mode. Terminal. Docker run -it. What is the name you want to give the container? You might be liking idli. Okay, guys. I know the Indian spices, guys. You can, if you have any other names, please do that one. Okay, so docker run -it -name idly. This is the name of my container. Okay, but from which image you want to create a container? So I need to specify this one here. I want to use Nginx, or I want to use HTTPD :latest. This is a tag. If you don't provide the tag here, automatically it will consider latest only. If you write here, no problem. If you don't write here, no problem. It will take latest only. So let me hit now HTTP image. Now what has happened? It started running in the foreground. I need to stop it. And now again, I execute the same command. I will show you how to execute it. So now let me go here and I will use something called as another name, samosa. You might be liking it, but now I want to use -d option. If I don't use -d option here, then my container starts running in the foreground only. But if I want to run this behind, if I want to run as a daemon or detached mode, so that it will not come on the as a it is not running in the forefront. Okay, I need to stop it. So I will use -d option. What is -d option? -d option is used for detached mode. Detached mode, guys. I'm so sorry, the spelling is. Okay, detached mode. What is the -i? -i stands for interactive. And what is a T? Everybody knows about T, right? It is a TTY terminal, TTY terminal. You can see here, this is TTY here. It is PTS1 here. So run this interactive mode, but in the detached mode. So run in the background. Don't run in this in the foreground. Now you see here, how to see whether the running, this is container has been started, guys, and how much time it has started. Let me run one more container, guys. I like to run multiple containers. Run -it -d -name. Now this time I will use something called as burger, and I want to use the same image to create another container. I can use another name also. Let's say vada pav. So this is my third container. Now can you see here? Now how to check these containers are started or not? Are they running or not? You can use command docker ps. So these are the containers started, guys. One of the name is vada pav, another one is burger, third one is samosa. So I have created 3 containers from same image. Okay. So how do I delete this container? How do I access this container? There are a lot of things, guys, are there. Okay, we will be definitely continuing that in the coming session as well. Let me just show you how to delete this container. I can use rm-f. Vada pav container I want to delete. Is this deleted? I want to delete this burger. It can be deleted. I want to start this container. Okay, I have only one container now. That is samosa. I can stop this container. Yes, docker stop samosa, and I can start it also. And we can delete it also. Okay, so now see what I have done here, guys. I have fired a lot of commands till now. So what is -d option? It is detached mode. What is -i option? It is interactive mode. What is -t? It is terminal mode. So you will get interactive terminal mode, and this particular stuff will start running in the background. So how to see whether the running containers are there or not? Right now, I don't have any running containers. How many images I have? I have 3 images, 2 images now. So guys, did you understood how to search the images? How to create the containers from the images? How to delete the images, and how to stop the containers, and how to delete the containers? Okay, guys, I hope that you have understood this much point. If you have any questions now, I can take the questions if you want. That.
Yeah, Ramesh,
Covered some of the questions.
I
Let me
have a
pick one by
question.
one. Guys, sorry, we're going to go via the chat window. And if you have questions, you need to wait till we pick up, because we need to honor the guys and respect the guys who have picked up in the chat window. Thank you. So when do you use Docker Dash version, we can see client and server. What is the difference between them? Good. So what happens is client. Okay. So Surendra, when you're connecting, you have one machine which is, or do you want to answer that, Ramesh?
Yes, if you don't
Yeah.
mind.
Yeah, please.
Okay.
Please.
So, guys, if you install, let's say that you have installed the Docker version. Let's say this is my Docker version. I have a very nice Linux machine I have installed here. Okay, but I don't want to access this Docker from this machine. I want to access it from some other machine. Okay, so this becomes my server entity and this becomes my client entity here. So you just need to install one Docker utility here, and you can easily access the Docker container from other machines. So normally, if this is basically comes on, you have a Docker container or EKS we have installed, we need to have the one client machine from which we want to access the wherever the Docker you have hosted, right? So that is your client server architecture. So I can access the Docker containers from other machine also, but I need some Docker client software for that one. Is that clear?
Thanks. Thank you. Now one, Abo's very good question, and now I know we are a little bit more ahead. There are a few questions. We can pick these questions in the in WhatsApp group or tomorrow, because I know you have to leave as well. You're already late. Can you answer that, or should we take these questions
No,
tomorrow and we'll pick up?
If there are a couple of questions, I will definitely take. No problem. We can
Thanks.
spend
Thank
time.
you very much. Appreciate it. Really appreciate it. Okay. So one thing, there was a question about I forgot. Go down and very quickly we'll keep it short and quick. I forgot, where is that?
From which we should take now?
Let me
can
go
we
back.
spin up? Okay.
Above where he was, 1 second. Man, sorry. Yeah, if you have Docker running and you happen to stop the engine for some time, Docker, do you have to restart the Docker before you continue where you stopped? Is it possible to continue from where you stopped, or you have to retype all the steps on the lab? I'm not sure. Yeah, sorry.
So basically, what happens actually? Let's say if I stop the Docker here right now, all the containers will also get stopped. And when I start the Docker engine, then I have to start the containers manually.
Thanks. Yeah. So when we stop the Docker process, or when we stop this machine, all the containers will be down. So you need to start, but you don't have to pull that image again. The image is already there. It just start and stop of that above. Yeah.
Right.
Thanks.
Yes. You don't have to pull the image again. Correct.
Yeah. The path is constant in all machines. Anthony, can you unmute yourself? And yeah, path is constant in all the machines. That's right. Of Ubuntu type. That's right. The path is constant. Got it. Yes.
Path is constant everywhere. In CentOS also you will have same path.
Yeah, CentOS and Ubuntu, it will be same. That's right. Atul, using Oracle VM box and installing Ubuntu there would be enough for this course exercise, installing Docker and all, or only the Azure and one option is recommended here. So Mayur, for Docker machine, for Docker configuration, you can do it on any Ubuntu you get, whether you got on your local machine or your laptop, or you can do it on Azure Cloud, AWS Cloud, Google Cloud, anywhere. When it comes to Kubernetes, we would ask you to do everything on Azure Cloud, because later in later in Kubernetes class, we have a more advanced topics like load balancer. We have shared mount point, shared storage, and other things. These we have tested it on Azure Cloud, and we probably might work on AWS Cloud, because we are seeing a lot requests on that, but it might take time. So if you hit any problem on those advanced topics, you will need a load balancer, you will need an underlying shared mount point, shared storage, or etc. We will not be able to support it, and hence we are doing it on Azure Cloud. Okay.
Thank you.
Dan is saying, where do we use RMI and where do I use RM-F? Okay, so
Yeah.
RM-F is for the RM-F is for the operating system. You're removing the file. RMI is for the images. If you want to remove images properly, you need to use RMI. Anything else?
To delete the container also you can use RM-F.
Oh, you can use. Okay, sorry, I didn't realize. Okay,
Yeah.
good. Thanks.
You can use
So why would I
RM
use? Why would I use RMI? It's just like two different ways to do the same thing. Yeah.
right.
Thanks.
So if you want to remove the container, you can use rm-f. And if you want to delete the with the help of Docker command, Docker rm-f. And to remove the images, you can use Docker RMI. And if you want to delete the image file, you can use rm-f command.
So that image would be deleted in the local or like the Docker Hub?
No, from local machine.
Okay.
Only from the local, not from the Docker Hub.
We don't have rights to delete it from the Docker Hub.
Okay. Now, Chance is saying, are we going to learn how to house our own repository on-premise? No, we are not going to do on-premise. We can show it to you on the cloud. So we'll be creating on either Docker Hub, or you can create another image on AWS Cloud or Azure Cloud. We are going to on Azure Cloud and AWS Cloud. It's already given in the bonus, and I think it's on how to create a private repository on Docker Hub is also there. So we're not going to do. Thanks. Okay.
But we will be performing one activity on pushing the images to the repositories. How to push and pull the image.
Yeah, pull we have already shown. We are going to cover on one push how to push an image. You create an image locally on the machine. We'll be using Docker file to create an image, and then how do you push that? We are going to cover that as well. No, Anthony is saying, so you mean the images are not stored on local machine? They are stored on the local machine, but that's on your file system. And Anthony, can you unmute yourself if this is not clear? So images are stored on the local machine, but as like any other file. Okay.
Okay, the images are stored in our local machine, because from what he was explaining, he said, yeah, these images they are on the Docker itself. So I mean, but these Docker are located in our local machine from the Ubuntu.
No. So there are two things. One is images by default stored in Docker Hub, which is on the cloud. We are getting that image from the Docker Hub and storing it. When we start it brings and fetches the copy from the hub and brings and stores it locally on the system.
Okay. All right. Yeah, thank you.
Got it? Okay.
Yeah.
And when you're deleting that, you're deleting from the local machine. You're not deleting it from the hub or cloud. Great.
So,
yeah.
Atul, my question is, so once you have downloaded the images into your local machine,
okay, yeah.
Then when you when you run a container using that image, actually, that time, the Docker engine has the access to the local machine, right? Those folders, correct, by default.
Yeah.
Because we were discussing, right, otherwise how it will load the image actually, and then
correct.
Correct. Yeah, no, it will have access to the local machine. That's what we need to do. Yeah, it's already enabled by default. So Docker can access that. Yes. Yeah. So Docker will always fetch or check first local repository, local machine on that machine where your Docker is running. If it's not found in its default location, then only it will go and fetch it from the Docker Hub. Okay. Partha is saying, how do I know whether the image which I'm picking needs to handle the license by the user, where it's placed? I can refer to provided by advice to the customer. Okay. Is there any easy way to see license included or no license not included? Ramesh's question is, how do I know whether the images which I'm picking needs to handle the license by the user?
Yeah, basically all the images which are there, and if you are going to use it for the production purpose, you need to see if you are using open source images such as Ubuntu or such as MySQL, they don't have a licenses. Licenses will be required in case you have Windows images coming up, and then it is similar the way you are doing for your normal machines. You have to procure the license for the content also, and you have to put it there. Otherwise, it will not work. You have to use the same licensing mechanism like for what you are using for the Windows or other products.
Thanks. Okay, Surinder is saying Docker space search space HTTPD. This command searches for the Docker Hub. No, this command will be looking for the local machine. Is that correct? So when I'm typing Docker space search space HTTPD,
this will go to the Docker Hub to search.
This will go to the Docker Hub. Sorry. Okay, thanks. Thank you. Okay, thanks, Surinder, for asking this question. I'm learning every day.
Even if the image is locally available in the server, still that command will always search in the Docker Hub?
Yes. That command is meant for that only. It will not search locally.
Okay.
If you want to search locally, you have to fire the command Docker images, not
Docker
Docker search.
images. Okay, thank you.
Okay, dash name is the namespace which is created the Docker. No, dash name. Okay, when
This
we are
one is the
using
name.
option dash name here.
This is the name of the container.
So it's not the namespace, but it's a name of the container. Okay,
yes, name of the container.
What is interactive terminal IT? The command, what does it do?
So whenever we log in into the container, right, that time we should get some bash prompt to fire a command inside the container. Okay, so that time we need to have the interactive session, interactive terminal to talk to the container. So that's why it is important. So I cannot type the command inside the container if I don't have the terminal here. Okay, so it is an interactive terminal so that I can log in inside the container and I can type the commands also. So that is we are enabling here.
Great, thanks. So
you have mentioned
this particular exercise will be done tomorrow's session, guys. I will show you how we can log in.
Hold that question till tomorrow. We'll go in a little bit more in detail about IT, and then there's another method was there, and how do you execute another thing. So hold that question, IT dash hyphen IT question.
I will show you tomorrow how to execute that all the stuff.
Yeah. Okay, Piyush has already answered. Sumanta is saying, although here in the container using dash D foreground. Sumanta will cover that tomorrow. Okay, IT and dash D will cover that tomorrow. Hold on. All containers use the same port? No. Again, we'll cover that port number. We'll go detail. Right now, we're giving a very high level overview. We'll go much deeper into this is day one, guys, and this is very 30,000 foot view. So we'll cover that. These questions, keep these questions coming. So containers can use the same port. Are all containers use the same port? No. You define within the container. You write. Sorry.
I'll just answer here. If I am using the HTTP service image here, and from the HTTPD I am creating 100 containers, all that containers will have a same port. But how they will communicate, that we'll see in the networking. If I am creating a container from the Nginx image, Nginx might be using a different port. I hope that answers your question.
So each application, when you define a container, when you define an image, in that time, developer or someone who's written that image will tell what port number that process is listening. So if I say HTTPD listener, I might run it on port 80. So developer might configure that image to be listening that my HTTP listener on 80 or 90 or 100 or 8080. Similarly, Nginx container will be, let's suppose they can run it on whatever port they define, developer have defined and created an image. Now, when you spin off that image, whatever containers you run from that image, they will all use the same port. So let's suppose you have container one and image one and image two. Those two images might be using different ports, but any containers that you're running from the images, they will use the same port. And then how they communicate, we cover as. Vipasha, don't worry, we'll cover these modes tomorrow again. This is to give you a high level overview. You can't delete promote. So question is, if I delete the image where corresponding container is running, it will not let you delete. It will say to first stop and remove the container, then only you can delete the image. Detach mode means, Anthony, we're going to cover in detail tomorrow. What is the difference between Nginx and HTTPD? Nginx is a load balancer where HTTPD is a web server. KYC, these are standard things, and we'll use Nginx and HTTPD later when we do the more further loads. Mayur is saying using Oracle VM box and installing Ubuntu, there could be enough for this course. No, as I said, it will be enough for you to do Docker. But when we go to Kubernetes, then I would suggest Azure Kubernetes, because in later, Kubernetes also you should be able to do, but Kubernetes will struggle if your networking is not correct. And it's difficult for us to solve your networking problems on Ubuntu, on your local machine. And that's why we recommend everyone to go on Azure. Moreover, when we go on to Azure, there's more advanced things on Azure. Like load balancer and shared disk space and other things as well. Okay, Priyush has already answered. Can we spin off a container from a Docker Hub portal? No, not directly from Docker Hub portal. Sumanta, you have to download that container, that image first, local machine, and then you'll spinning off. If we stop container engine on the host VM, would it stop all the containers? That's correct. So the question is, if I stop my Docker engine, all my on the host VM, then all the containers will stop. That's right. That is correct. Okay. In this example, where we are mentioning CPU memory, Karthik, in this example, we are not. We are letting it to use as much as is. When we go to later, we have further labs. In that, we are going to cover that about restricting CPU and memory. In this lab, we are.
request and limit we can apply, right?
Yeah, we can apply, but we are not doing it right now. We'll do it later. We can't do, okay, so I think Piyush has already answered that. I think at a Docker level, Piyush, we can do that as well, right? Or no? We'll cover that in lab. Stay tuned on that. Is the image started on VM stand for Docker engine? Is the image started on VM stand for Docker engine? Kabez, yeah, can you unmute yourself? I'm not sure about your question.
Yes, please.
Can you unmute? Can you? Your question is not clear. Can you explain the question again? Is the image started on
Okay.
VM stand for Docker engine?
Well, let's say we started HTTPD, right? And then we create
container out of it.
If I start HTTPD, does it mean it's a Docker engine?
It starts a Docker container. So when we start a HTTPD from this, what we are doing is we are starting a container. Or inside that container, my HTTPD server is running.
Okay.
So Docker daemon or Docker service is already running. On that Docker, we are starting a container. So yeah. Okay, so the HTTP server is a container running on top of a Docker engine.
Right. So it is basically image, and image starts the container, and inside the container, it actually extracts and it starts the service inside it.
And
so we'll
later
we'll see
and
that
later in next 2 or 3 days, we will go more into these images and diagrams and other things that then things will come much more clear. Yes, Thompson, we have a labs on all these commands are there in the guide. Yeah. Okay, Piyush, do we mention the Docker service registry path in the Docker file for every microservice? No.
Not required. As such.
Not required, Ashish. Can we delete the container while it's running?
Yes, we can delete it.
But it will first stop. So when you say delete, it will go and stop and then delete behind the
Delete
scenes.
it, yes, right.
Okay, 1 second. Okay, no, we have to stop the container. Okay, delete. Okay, correct. What are the detached means? And Anthony, detached we are going to cover later tomorrow. Both file and image means the same. Yeah, you can say file and image means you can use word interchangeably, but image is a copy from which you can start the container. That actually behind the scene is a file only. Okay, okay, fine. Karthik, what is the similar guidance CKD, please? Mila, you ask a question inside the WhatsApp group, team will share that link tomorrow. What is the command to see local images after running Docker command? I think Aditya, can you show one more Docker image is already given here, Aditya. Thanks. Piyush, which we are pulling, okay, 1 second, Mila, okay, 1 second, we can call it either image or file. Okay, fine, Piyush, Praveen. Are these new sessions going to be on Saturday and Sunday? That's right. So these, Praveen, these sessions are going to be every Saturday and Sunday. And today we have done 30 minutes extra. So tomorrow maybe we do 30 minutes less. I don't want to overdo but make sure that we help. We take questions like these sessions at each logical point. We'll stop them. Okay, so these Saturday, Sunday, Praveen, parallelly we are also doing a weekday batch currently, which is every Tuesday and Thursdays, and you're more than welcome to come there. But there we are a little bit ahead. We are doing Kubernetes classes there. Okay, Dan is saying, please can we have the command line history? Yes, we are going to share that, Dan. Okay, brilliant guys. Did we anything explicit for the SC Linux? No SS by in Ubuntu, that's already there. We don't do anything explicit. We don't do setup. By default, it's enabled. Some companies might disable SC Linux. You need to enable the SC Linux there. Then. Okay.
On Ubuntu, you have to enable that one. We have to enable on the Ubuntu. In Red Hat and CentOS, it is already enabled. That is the only change. Yeah, SC Linux.
Okay, great. But all the whatever you need to do, these are all covered inside the guide. So just follow the guide, and then if any thing is not clear in the guide, let us know. Okay, so when you're installing the Docker, Sudhakar is saying we use apt docker -y. How do you know if Docker is community edition or a professional edition? Very good question. When I'm installing Docker, how do I, because we are using star, I think we're pulling up everything. Is it a Docker community or is it a Docker enterprise?
Community. It will not allow to install enterprise.
It'll out. Okay,
What
good.
is, yeah.
Okay.
We have to explicitly define that command to download the enterprise edition.
Okay, great. Thanks, Piyush. Where can I download the E version of the Docker? So you can go to Docker, and then I think we have not done it on E because there's a paid version. You can reach out to Google or Docker. They'll be happy if anyone for that. So Docker E, I think you need to connect to Docker, and they will give you. You need to pay some license and everything. Okay. Okay, Santosh, can we make the classes 11 p.m. IST and 11? I'm not sure. Hold on. Okay, we are planning to restrict the weekend sessions to 3 hours. Sumanta, I need to double check with Ramesh, and then I'll come back to you on that point. The session. How many sessions in this training? 1 second, Andre. We mentioned at the start when we did, I think for first 15 minutes, I mentioned about how many sessions, but we'll post it in WhatsApp group again. We'll post it in WhatsApp group. Vipas is saying, can you show us where to enable the Ubuntu SC Linux or SC Comp? Do you have that command handy? Yeah, sure, please. Thanks. And
I
we'll
will
wrap
show
it
you
up
tomorrow.
now.
Don't worry. I'll show you tomorrow.
Oh, you'll show. Yeah, thanks. No worries, Ramesh.
I have a
Guys,
question,
cover it tomorrow.
Atul.
Yep.
So you said, if I have to delete the container, then I have to delete the image first. Okay. So what does that mean?
No. I said if you need to delete image, then you need to delete container, not the other way.
Oh, okay. Thank you.
Okay. So you can stop or you can delete the container, image will be there. If you want to delete image, then you need to make sure that any container that you're using that image is deleted first or stopped
But
first.
then that doesn't mean that, image is a template, because
Yeah,
template
image is
is.
a template only. Yeah, image is template. You're
So
spot on.
how can you say that? Why? Because, there is still a link between image and container.
Yeah, so using image, you're creating the container. So you can delete the
Yeah.
container, but you're not deleting the image. But if you want to delete the image, then you need to delete the container because you're spinning off container from the image, not the other way.
I understand, but then, because there is some link, soft link or whatever you say, between a container and image. Why? Because image is not playing a role only as a template. Okay, there is still link between container and image. Okay, otherwise, yeah.
We will do one thing. I will show you that how to do that tomorrow. We'll see that.
Oh, okay.
I will show you that how we can delete the image even container is running, but that has some little drawbacks are there. Okay, so I will show you that tomorrow how to do that. Okay, just wait.
Okay, thank you. And when we are talking about the recorded session, okay, in the recorded session, are we going to have, are you going to get the same, live session what Ramesh has shown us now, or?
No, so there are two things. Okay, so there are two things. One is well done videos which are done by me and Mamta. They are on the portal, which is under self-study mode, which is Kubernetes self. Yeah. There's the under live, there'll be banner called live. Inside that we'll upload, and not only today, but we have all the previous weekday, all the bonus classes, everything till date we have done. Those I think from last 1 year we have all or last 9 months.
Are we going to remove anything from this recording?
No, we are not going to remove anything. No, we'll not remove.
Right?
So they are there from the
session is starting from 10 a.m. Canada time, because I have
unfortunately no, because then it comes whatever becomes is it becomes then can please restrict all weekend session for 3, because for India guys then it becomes too late. There are the guys from India as well.
No, okay, we can run for 3 hours starting by 10 a.m. EST if possible. I'm not
no, I don't know to start date our time. I don't want to, because then it becomes too late for guys in India as well. Okay, so let's talk tomorrow. I'll be there for I may or may not be there, but Piyush will be there, and I think Ramesh does much better than job me. I'll be there to see, but as I said, he is expert in Docker and Kubernetes, and I think from tomorrow we're going to do more hands-on lab. You will have fun. Anyone who need help with the lab, please make sure you ask in WhatsApp group. Piyush, not just Piyush, Ayush, Surbhi, and we have around I have 15 or 20 guys in the tech team to support you, so not to worry about. Okay, 3 hours. There is a lot of demand coming for 3 hours, Ramesh. We might have to add some new days extra, but we'll probably I'll see what best we can do. I know sometimes 4 hours becomes a little bit too much for live recording. We'll have the question discussions. when you say live session recording, yeah, whatever we are talking right now, everything is recorded. It will be there. Yeah. Thank you very much. I'm glad that you understood the concept. Thank you very much. We'll ask you to rate on the session. We'll love you to tell you if we need to improve, if we can do anything. I know there were questions being asked intermittently, but sometimes we let questions ask, sometimes we restrict, as long as it's related to topic. But I'll request everyone to hold that questions till we open up on the question answers and ask questions, everything inside our place.
Don't worry, guys. Everything will be cleared. Everything will be clear.
Ramesh, as I said,
Don't worry
Ramesh is
about
doing
it.
our weekday, and one of my my sister-in-law is doing a weekday, and I'm getting excellent feedback. She's very demanding, and if she says that Ramesh is good, Ramesh is good. I've attended your sessions, Ramesh, so no doubt about it. Guys, hold on. This not here, guys. Don't rate here. Maybe in WhatsApp group, please. Thank you very much. WhatsApp group, please. Piyush, you should have asked in WhatsApp group. Okay, thanks. Thank you. Thanks, everyone, guys. I'll be ending.
Actually, this
Sure.
Azure account is similar to AWS, right? There also
Yes,
I'll have 1 year free, and also when I stop the instant, they don't charge, right? That's what my question was actually.
No, okay, so no, so they give only for 1 month free in Azure. But in Azure, in AWS, let's suppose you create a different machine. So in AWS, you create a machine of 8 gig, right? Or maybe 16 gig or 20 gig, you're charged for that, right?
Okay.
Even in free account. Whereas
So
in Azure, you don't get charged for that.
Oh, so the only difference here is like it's for 1 month and that's for 1 year. But again, here the capability of Azure is more. So maybe we need to use a different email in Azure than if we are using it, right?
Exactly. And again, if you want to go on pay-as-you-go model, because if you do the same lab in AWS also, you're going to pay because in AWS also you're going to go on a higher price and you'll be paying anyway. Whereas in Azure you'll get free, and then later you can upgrade your Azure to pay-as-you-go model, which is like 0.04 cents per hour, which is like if you do 20 hours lab as well, it'll be just $4. That too after 1 month free. Yeah, and 1 month should be more than enough to do all the labs. Yeah.
Okay.
Okay. Yeah, homework is tomorrow. Make sure you go through and create a lab, please. Create a Azure account and create a machine and install Docker and create a container. Piyush, make sure we post tomorrow. Lab is about this. I'll post it in a WhatsApp group. Lab is for tomorrow. Make sure you do create a machine and create a Docker, install Docker and play with a container. Okay. Thanks, everyone. Thanks.
All right, guys. Thank you very much. See you tomorrow. Have a nice time ahead. Take care of yourself.
Thank you.
Thank you.
Thanks, Ramesh. Thanks.
Thanks.
Bye-bye.
Thank you, Ramesh.
Thanks, Atul. Thanks, Ramesh.
Thank you.
Thank you, Ramesh.
రిజిస్టర్ బాగుంటుంది ఒకటి ఏదైనా సర్వీస్ తీసుకొని మనం